Well, hello everybody, and welcome to another exciting episode of Paleontologizing. We are here at the Utah Fieldhouse Museum in Vernal, Utah. I have with me today
Laurdee from Cooking with Laurdee. Usually I am cooking on Twitch, but today I am touring the museum with my good friend Danny.
Yeah, and I, of course, am Danny Anduza. Get feedback with that.
Sorry.
That's okay. I'm Danny Anduza. I'm a dinosaur paleontologist here on Twitch, trying to do some good old-fashioned science outreach. And yeah, we're on this amazing road trip right now, all across the American West, visiting different museums and other sites. And today we're here in Vernal, Utah. And there's actually like the main drag going through Vernal right there. And this is the Fieldhouse Museum. We're going to go visit the sculpture garden outside first and take a look at some cool sculptures. Most of these are from like the 70s, so they are definitely a bit out of date, but they're going to be fun. And we will hit this part first outdoors before it gets super hot. It's supposed to be really warm today here in eastern Utah. Then we'll go inside and see some more updated displays, much more recent stuff, and they've got some beautiful specimens in there that I'm really excited to show you.
I'm excited about these old-timey dinosaur representations.
You are?
To see like what your take is on them. So let's check them out.
Cool. Let's see. First off, we have up here a Dilophosaurus, not a dinosaur. This is what we call a Peleozoic. This is a kind of synapsid. These guys are very close to the ancestors of you and me, of mammals. So yeah, you're probably more familiar with Dimetrodon. That's another contemporaneous Paleozoic with the big sail on its back. This one is a Dilophosaurus, presumably an herbivore. It's got much more kind of peg-like teeth. Not really suitable for tearing through flesh. But I'll bring you over there and give you a better view. What are you saying, Laurdee?
Here is a little
Oh, holy cow! Thank you so much, Vice. That's half a year right there. Really appreciate your support. Yeah, check this out. A Dilophosaurus up there.
Let's protect our fossils.
Very cool.
If I
don't really know what's up with those kind of sideways projections that are jutting out from the side of that sail.
Subscribe.
I don't know what the function of those is. I don't know enough about Permian Paleozoic. Anyway, again, not a dinosaur. This is from tens of millions of years before the first dinosaurs. So yeah,
I saw on the sign
Yeah?
that it said the frill could be used for like heat absorption.
Oh, the sail? Yeah.
Yeah, the sail. How do you feel about that?
I don't know. It could very well be. I mean, it doesn't seem to be like a structural thing, like a hump, like on a bison or something like that. The vertebral, like the neural spines are much too thin for that kind of thing. It doesn't seem structural. We were talking about this yesterday when we were looking at the Dimetrodon. Yeah. But those lateral projections, I don't know what those are about. I actually wouldn't be shocked if that was, well, I don't know. Yeah. But pretty cool critter. Pretty cool. One of everybody's favorite, really charismatic vertebrates from before the dinosaurs. Yeah.
Castor Ball sub for the first time with Prime.
Holy cow. Castor Ball, thank you so much for that Prime sub. Really appreciate it. Welcome to Paleontologizing. Thank you for your support. A little thank you. Let me show you our first dinosaur of the stream here. A little Celopfisis. This is life size. I think they get a bit bigger than this. This is a really important early dinosaur. These are from the Triassic of Arizona and New Mexico. Yeah, Celopfisis, early theropod dinosaur. It still has, I think, 4 fingers on each hand, which is a primitive characteristic. But a very lightly built, very fast animal. And Celopfisis is... It's from a place called, it's famous from a site called Ghost Ranch in New Mexico. I think Georgia O'Keeffe might actually own that land, or she may have owned that land, or it has something to do with Georgia O'Keeffe. She lived in that part of the world for a while. Yeah, Ghost Ranch in New Mexico, hundreds, if not thousands, of Celopfisis specimens have come out of there. Just like a mass assemblage of Celopfisis. This is from a time when dinosaurs were not yet dominant upon the Earth. They were still pretty new. But clearly they were something very different from most other creatures around at the time. And at the end of the Triassic period, they basically end up taking over. A lot of these other, like, weirdo, kind of primitive reptile and like synapsid critters, they go extinct, and dinosaurs kind of hold onto the earth for a very long time after that. But yeah, Celopfisis, very important early dinosaur.
I like that this one has rosettes on it.
Pretty cool, right?
Like a tiger or like another big cat. Not
like
a tiger.
Like a leopard, or a jaguar. Yeah. Pretty neat. I wonder how often they've updated the paint schemes on here. On the side, it's got some stripes. Yeah. Pretty cool. I've actually worked with some Celopfisis material at Berkeley, the museum there. Really neat stuff. And one of the paleontologists from Berkeley actually debunked the idea that Celopfisis was a cannibal. There's these really famous specimens of Celopfisis with all these little bones inside their gut region. And they're clearly too big to be an embryo or something like that, if these animals gave live birth, which we don't think they did. And I don't know, Celopfisis is the most numerous animal in that area, so they thought it must be a baby Celopfisis. Those guys must have been cannibals. Yeah, but then it turns out it's actually a different kind of creature on the inside, called a silosaur, which is kind of similar looking. So yeah. I don't know, was that Randy Ermis or Sterling Nesbitt? It's one of those guys who works on Triassic stuff, who was a graduate student at Berkeley at the time, back when I was there in high school. So yeah, Celopfisis, cool animal. Very important to the history of dinosaur paleontology. It's one of those taxa that Edward Drinker Cope named. Between Cope and Marsh, Marsh was the one who really named most of the dinosaurs. Cope only really had a few, but that's one of his, is Celopfisis. Now, those of you who were here for the broadcast yesterday saw a mounted skeleton of this animal over here, Utah Raptor. This is about life-size. The proportions aren't quite right. And this was probably made... Well, Utah Raptor was only named back in 1993, and so this model would have had to have been made after that. But it's already grievously out of date. This animal should have feathers all over its body. Yeah, we now know these are very, very bird-like animals. If you were to see one alive, you would probably mistake it for a big, weird, ground-running bird. But, yeah, you would... It would be a mistake to not take this animal seriously. And, yeah. Pretty cool. Utahraptor ostromesi. I think Jim Kirkland named this back in 1993. It's become a really famous animal. Partly because of its name. Utah Raptor, it's associated with Utah. A lot of people in Utah are very, very proud of this dinosaur, as they should be. It's the largest of the dromaeosaurs. You'll see it's got that big sickle claw, just like on Velociraptor or Deinonychus. But this is the biggest member of that family. And, yeah. People also associate it with Jurassic Park. The Velociraptors from Jurassic Park, some people say that they're Utah Raptor. They're not, actually. Both the book and the movie Jurassic Park came out before this animal was widely known. Before it was even published, I believe. So those couldn't have been Utah Raptor. It was just kind of a nice coincidence that, suddenly dromaeosaurs are super popular because of this book and this movie. And then a giant dromaeosaur is found in Utah. This is going to be a really important dinosaur for theropod paleobiology in the next couple decades, I'm sure, because of some really cool finds. Laurdee, yesterday we were talking a little bit about the Utah Raptor block.
Yeah.
Yeah, that is going to yield some really, really cool clues about this animal. About its ontogeny, about possible behavior, and just osteology, too. We're going to have probably every part of the skeleton will be represented once that block is fully studied, I hope. So we'll have, Utah Raptor might become kind of a model dromaeosaur. It might become one of the best understood of these people call them raptor dinosaurs in popular culture. Paleontologists, we call them dromaeosaurs. Yeah. Anyway.
Do all the United States have their own dinosaurs?
Certainly not, no. Hawaii, for instance, is way out in the middle of the Pacific Ocean. No dinosaur fossils from there. Hawaii didn't exist yet. during the time of the dinosaurs. Hawaii's volcanic in origin. Most U.S. states don't have any dinosaurs from them. I think most states, like around the Gulf, Florida, Mississippi, Arkansas, Louisiana, no dinosaur fossils from there. Did I say Arkansas?
I'm not sure.
Arkansas has one, Arkansaurus. But yeah, it's Utah Raptor kind of. I'm trying to think of. There's Coloradosaurus, which I'm not sure if it's even from Colorado. Most I don't know. There are a few dinosaurs from different states that have the state in the name. Utah Raptor is really the most famous, though, of all those that I can think of off the top of my head. But yeah. Check out this mammoth right here. Woolly mammoth. There's a little placard in there that talks a little bit about the Vernal mammoth, so we'll see if we can check that out while we're going through the displays inside. But very cool. This is from the 1970s. It's held up surprisingly well for something that old. I wonder if they've refurred it at any point.
And you have to kind of think like a mammoth's fur would have gone through the elements and stuff, so
Certainly.
it would be matted and be kind of gross like this.
Absolutely,
you guys
yes.
probably can't see in the camera, but it's a little grungy.
It certainly is, yeah. Bet you they can see a little bit. Yeah. Pretty neat. It almost reminds me of like redwood bark or something. I wonder what it's made out of. What that material is. That makes up the hair there. I'm not sure. Any clues, Lordy?
No, I have no idea.
Huh.
No idea.
Well, right here, we've got a lovely ornithomimos. We've been seeing plenty of these on this trip. We had a skeleton of an ornithomimosaur at the museum in Salt Lake, and 2 of them yesterday at the Museum of Ancient Life in Lehigh. And here is a fleshed out ornithomimos from the 70s. So this is a time when everybody kind of assumed that most meat-eating dinosaurs kind of walked upright, like with their tails kind of dragging on the ground like a giant kangaroo or like Godzilla or something. So that's what's represented here. This animal should be standing with its backbone parallel to the ground, like that. Instead, it's like upright, like this. But this is how we used to think they looked. It's got those kind of Mr. Burns hand thing going on there with the wrists. We now know these animals walked with their wrists kind of, with their palms facing each other. So with their wrists articulate. And this animal, like the Utahraptor, should be fully coated with feathers. These are called the ostrich dinosaurs because they superficially resemble ostriches. It's got that long neck and long stilty legs. Unlike an ostrich, it has a long bony tail. And prominent arms on it like that, but it should be fully feathered, so it would look even more like an ostrich nowadays in a modern reconstruction, which is kind of cool. Like ostrich dinosaurs, it's not really a misnomer. They're even more ostrich-like than we thought back then. And over here, I love this one, Stegosaurus. This is... There's a certain kind of, like, gracefulness in these super, like, cumbersome, like, mid-20th century representations of Stegosaurus. This animal is altogether way too big. We're actually going to see a cast of an actual Stegosaurus skeleton later on in the museum here, so stay tuned for that. But take a look at the proportions on this right now. Big, chonky animal. They were actually more graceful than this in real life. More slender, more svelte. You can see the elbows on the arms kind of bowing out to the sides a little bit. We now do not think that they did that. They held their limbs directly underneath their body. And those plates, it's kind of funny. The plates on here are not... They're cool and they're prominent, but they're like not as prominent as I would make them in a sculpture. These should be like the focal point of the animal. Instead, they're just kind of along for the ride on this one. I think it's because the rest of it is just so thick. The head Stegosaurus is a pretty small head compared to its body size. This right here, this is probably twice the size of an actual Stegosaurus skull. Yeah, this animal is too big, but I still love it. It's really cool. don't know. Some of these classic dinosaur reconstructions, they just have so much charisma that I can't be too mad at them, you know? Look how thick the end of the tail is. Look how long those spines are. Those tail spikes. Alright, we're gonna walk around the corner over here. Oh, see a bit of a tail peeking out there? Who's this gonna be? I know who it is. Does anybody want to take a guess real quick? Which dinosaur is this gonna be right here? If you guessed...
Raptor.
What's that? Raptor?
Godzilla.
Ooh. If you guessed Celopfisis,
We all knew if it hadn't been for that great dinosaur.
You were completely wrong. This is Triceratops.
We would all be.
a very, very antiquated
Loving the
Triceratops.
Oh.
Look at how the limbs are sprawling out to the sides right here. This is not how Triceratops were. Yeah. Not like that in our modern reconstructions. It's kind of funny, like they thought it was such an ungainly animal. Because here's the back legs, and they're pretty much, you know, column-like, just going straight down to the ground. There's an ammo can back there, that's funny. I wonder what that's about.
Couple things. Fortuitous bounce.
Yeah?
10 months. Says loving the field streams.
Hey, Fortuitous Bounce, it is great to have you here. Thank you for those 10 months. That's almost a year there. Holy cow. Wonderful.
And then, is there a good modern science website that has pictures of dinosaurs that are close to current knowledge?
Oh, off the top of my head, Gesundheit. You know, Wikipedia is actually a pretty good source for that. Wikipedia, if you're looking for up-to-date dinosaur information, you really can't do better than Wikipedia. It gets updated so quickly. Sometimes it's like, before an article even really goes public, like before the press gets a hold of a new dinosaur publication, it's already there on Wikipedia. There's already an article. So check Wikipedia. Yeah.
An important one, who I think is new, says get a bunch of feathers, breaking the museum at night, glue feathers on all the dinosaur models.
That would be a lot of work, and I don't think they'd be very happy about that. Yeah. So Triceratops here. This is cool. Like, just the shape of the skull. That's the thing about Triceratops. We have a lot of specimens of Triceratops nowadays. We had over 100 just at Museum of the Rockies, where I used to work. Worldwide, there's probably between 500 and 1,000 Triceratops specimens in museums. And the skulls vary a lot in shape for a lot of different reasons. You've got different growth stages. You've got different, like, stratigraphic horizons for Triceratops. So, like, at different points in time, you know, they evolve so that the skulls look different. This one right here is very reminiscent of O.C. Marsh's original Triceratops, like the holotype, which is somewhere on the East Coast. I forget where. It might be the Yale Peabody Museum. That would make a lot of sense. But yeah, this particular one, very reminiscent of that particular Triceratops. Looks like one from the lower Hell Creek, probably, Triceratops horridus. But yeah. Yeah, but as I was saying with the limbs, you know, the back legs, like a dinosaur's limbs should be, just going straight down to the ground. Very upright, columnar limbs. But in the front, what's going on here? You've got these elbows sprawling out to the sides. It's like this animal would constantly be like the back legs would be moving faster than the front legs. Wouldn't go well. Now we know that the front legs are much more upright than this. Would have been a much more graceful looking animal, head held off the ground. Right here, it's like he's doing some push-ups, struggling with them.
We got 5 gift subs from Fortuitous Bounce.
Holy cow, Fortuitous Bounce! Thank you for the 5 gift subs. Wonderful. We might make the goal for today's stream. That would be awesome. Cool.
Why is there an enrichment of Triceratops fossils?
That's a great question. Well, a lot of it is geographical. So Triceratops it's from the Hell Creek Formation and the Lance Formation in the western U.S. and I guess even going up into Canada, there's some Triceratops fossils too, in like Alberta and Saskatchewan. Triceratops was around for a good while, like a good probably 2 to 2.5 million years. So there's a lot of time for those fossils to accumulate. And Triceratops is just really charismatic too. A lot of people have wanted to go out and find more Triceratops. It was the first like really well-known ceratopsian dinosaur, first well-known horned dinosaur to be named. So yeah, there's part of it's historical, part of it's just that we have a lot of specimens. There's a lot of places where you can find them, and yeah. Triceratops also became really popular kind of early on in the study of dinosaurs, and so you see it in a lot of popular reconstructions. That's why it's in every kid's dinosaur book and every assorted pack of plastic dinosaurs and that kind of thing. Yeah. And over here, of course, we have Tyrannosaurus. You can't have Triceratops without Tyrannosaurus too. These two dinosaurs were contemporaries. We know that Tyrannosaurus ate Triceratops. We've got lots of evidence of that. Bite marks on Triceratops bones that come from T-Rex teeth. This T-Rex is a little bit too big. It's very chunky. It makes it look even larger than it is. And it's got that same upright pose like the ornithomimosaur model did back there. So this animal, we now know, held its spine horizontal to the ground. It was a lean, mean, very efficient animal in the sense that, at least in the sense that it wasn't plodding around like this with its tail contacting the ground. It's not Godzilla. It's more like an ostrich or something like that. But, with a much bigger head with much more fearsome teeth. Yeah, Tyrannosaurus, pretty cool. It's getting hot out here, so we're going to continue on, I think. I think Laurdee will appreciate that.
I'm good.
And we've got to come back around this way anyway, so we can pay the Tyrannosaurus another visit. Speaking of horizontal posture for theropod dinosaurs, let me show you over here. We've got a lovely Allosaurus. I love the paint job on this one. Yeah, let me show you. This is much newer. This must have been done in the 80s, I think. There we go. And I wish they'd trim the trees around him. He's kind of obscured there. But yeah, Allosaurus. This is actually Utah's state fossil, Allosaurus fragilis. Really, really cool. I love the paint scheme on it. The gait's a little awkward. How would you replicate that, Laurdee? Yeah. Kind of a prancing pose for the Allosaurus. I love the stripes on it. Yeah, again, I wish they would trim these trees so you could see it from the road. But, really cool. Again, it's got the spine horizontal to the ground, parallel to the ground. This is how this animal should be posed. And this is a decent-sized Allosaurus. They get maybe a little bit bigger than this. Unlike Tyrannosaurus, it's got more powerful forelimbs, big claws, and then 3 fingers on each hand rather than the 2 on T-Rex. I feel like that was one of the first things I ever learned about dinosaurs when I was a little kid. Before I was 2 years old, I could tell you the difference between a Tyrannosaurus and an Allosaurus, no matter how crude the restoration, just based on the number of fingers. I feel like that's one of the first things that any dinosaur-obsessed kid learns, is how to tell the difference between an Allosaurus-type theropod and a Tyrannosaur. Yeah.
What does the Versissilis translate to in common speak?
I have no idea what you're talking about, random bug. Versissilis? I'm not sure. Yeah. I don't know what you mean. Is it something that I said? I'm trying to think of terms that I've been using.
So did you always know you were going to be a paleontologist?
No, I thought I was going to be a dinosaur for a while. But no, pretty much, yeah. I mean, every child I feel might be a little bit fickle and this week they want to be one thing, that week they want to be another thing. But I pretty much always knew that I wanted to be a paleontologist. after I recognized that I couldn't actually grow up to become a dinosaur. So, yeah. I feel like I've been really lucky. And not many people get to pursue their childhood dreams like that. And, you know, it's pretty cool that I recognize how fortunate I am and how uncommon that is. And that's why I'm here sharing it with you, you know. Yeah. We've got a lovely pterosaur right here. Pteranodon. And there's a wasp crawling into its nest right there. Just flew out. Probably got a wasp nest inside. But yeah, this is about the right size for a big Pteranodon. This one may have even been renamed recently. We used to call this guy Pteranodon ingens, or ingens is the species name, with the kind of long, skinny crest coming off the back of the head there. Right there. It might be a different genus altogether now. I'm not sure. But these guys lived in North America during the late Cretaceous period, back when there was that big seaway right in the middle of the landmass, kind of cutting North America in two. These guys would have eaten fish. They probably, I would imagine, kind of dove into the water in order to catch fish. It's kind of hard to imagine them skimming the surface, but maybe they did that too. But I picture them being kind of like giant pelicans. I wonder what the current consensus is among pterosaur researchers on the feeding ecology of pterosaurs like Pteranodon. By the way, not a dinosaur. So yeah, a lot of people in the general public will call these pterodactyls, and they think that they're a kind of dinosaur. No. They are very closely related to dinosaurs. It's kind of as close as you can get to Dinosauria without actually being a dinosaur. But they are distinct. These guys split off just before the origin of the first dinosaurs.
A random bug was asking about Fragilis.
Oh, Fragilis! That's the species name for that species of Allosaurus. There's a few different species. Allosaurus fragilis, Allosaurus atrox, Allosaurus jamadsoni, named after Jim Madsen. But yeah, these are just the two-part scientific names. You've heard of Tyrannosaurus rex. Tyrannosaurus is the genus name. Rex is the species name. For us, Homo sapiens, Homo is the genus name. There used to be a lot of different species in that genus. Now there's just one, Homo sapiens. All dinosaurs, in fact, all animals, really all living things that have been scientifically described have a Latin binomial like that, or some kind of, they have a scientific binomial, a two-part name, genus and species. So yeah, Pteranodon ingens. Ingens is that particular species of Pteranodon, the genus Pteranodon. And these guys here, does anybody know what these are supposed to be? I would love to see some guesses in chat. These are not a dinosaur. Just to give you a hint. Yeah. They are thick smoked potato. Indeed, yes. These lived before the dinosaurs. They're from the late Permian, I think? Before the big Permian mass extinction? Mayor Space has got it. Kudos to you, Mayor Space. Moss chops. Yeah. What a fun name. It almost sounds like a dish that you might eat. Moss chops. But yeah, these are, if I remember correctly, dinocephalian therapsids. So these are, again, closer to you than they are to any dinosaur. Closer to me, too. These guys are related to the ancestors of the mammals. These are big herbivores. They've got these ridiculous teeth right here. Oh, man. Yeah, look at that smile. What are you so happy about, Moss Chops? It's almost as though it knows something we don't. Ready to go look at this big sauropod, Laurdee?
Yeah. Danny, were you ever a Digimon fan, since some are based on dinosaurs?
No, I never was. Yeah.
How often do you think that happened as a rule with other close species of critter? Could have happened in dinos causing third evolutionary paths.
I'm not sure what you mean by that.
I'm not sure what we're referring to, yeah. Oh, interbreeding of similar species, that is.
Oh, yeah. I had a long discussion about this with some colleagues at one point, about like, could we recognize hybridization in the fossil record? And we basically, without like huge sample sizes and like accounting for all other variables, stratigraphy, ontogeny, taphonomy, everything else, without like all your unified frames of reference accounted for, recognizing hybrids in the fossil record would be extremely difficult. So, yeah. Hybridization is such a fickle, kind of fleeting thing. I feel like without DNA, it would be really, really tricky to prove that, you know? And of course, we don't have dinosaur DNA yet, so as for Mesozoic dinosaurs, hybridization, yeah, it's tricky. It's very, very rare, like, so many things have to go right before you can get hybrids in the first place. You have to have species that have recently diverged that, for whatever reason, decide to come back and interbreed again. And, yeah, you can really only have that with sympatric speciation, and I'm not sure how common that is among dinosaurs. Anyway, we're getting well into the weeds here, so before we fall further in, let's continue on. Speaking of weeds, not really weeds, but these beautiful plants right here are horsetails. They are. These might be genus Equisetum, or there might be another one. But these were alive at the same time as the dinosaurs, and it is really cool to see them here in this garden. These are the kind of ground cover plant that just go nuts if you let them. They spread via rhizomes, so they don't have seeds, as far as I know. Not in the way that we're used to thinking of them. These guys, and they don't really have proper, like, vascular roots, either, as I understand it. They have rhizomes, basically like little hairs that kind of spread through the soil. And so these will just take over any area that you put them in if the conditions are right. I've seen these, like, planted in somebody's yard, and then across the street, they're starting to come up in somebody else's yard, where, like, the rhizomes apparently went under the street and back up the other side.
Are they edible when prepared a certain way?
Horsetails, they might be. I know that there's certain species that, like Native Americans, First Nations people, they would use them as, like, scouring brushes, where you'd, like, take a bunch of them together into a bundle, and then they're so like cellulose rich, they're so scratchy that, like, you could use them for cleaning stuff. That's why they were called scouring brushes by English-speaking people. Yeah.
Okay.
Anyway, we've got a tail right here that just keeps on going. And we'll show you where this tail leads. Check that out. I think this is supposed to be Diplodocus. Looks too thin to be a Patasaurus, especially for... Yeah, Diplodocus. Very cool. Classic long-necked plant-eating dinosaur. This is your kind of archetypical sauropod. I'll show you why in a minute. And look at that. So, see how it was, like, kind of dragging its tail along the ground there? We now know they did not do that. Dinosaurs, as a general rule, did not drag their tails. Their tails were very functional for the most part. They're muscle attachment points. They were used for defense, maybe for communication, for balance too, in a lot of dinosaurs, especially the bipedal ones. So, and in basically every dinosaur trackway we've ever found, there is nary a single trace of tail. If the tail were dragging around on the ground, you would see tail drag marks in these trackways, and we pretty much never do. So that's, yeah. We used to think that dinosaurs dragged their tails, back when paleontologists thought of dinosaurs as being much more reptile-like, you know? Nowadays, we know that they're much more like birds. So, yeah. Very active, warm-blooded animals. Not really lizard-like at all.
What's your opinion of that find that might have been a landslide/burial event triggered by secondary impactors at the KT event?
Oh, that's a great question. Who was asking that?
That's Enginuber, I think a newbie.
Oh, awesome. Hey. Welcome to Paleontologizing. That's a fantastic question. I think the jury might still kind of be out on that. I've not read any of these papers, like the There was that one... Here, let me go stand over here in the shade. There's that one paper about the tsunami deposits in South Dakota, I think. And there was another one that just came out from, I think it was from Georgia, that had ripple marks that were 100 feet high or something crazy like that, that may have also been a result of a massive tsunami from the KPG impactor. I don't really know enough about that to really have an opinion yet. I haven't even read these papers yet. They sound really cool. I mean, I hope that turns out to be true. But I don't know yet. Yeah. I'm sorry, I don't have a hot take on that.
Is there any evidence of prehensileness in some of the larger-tailed dinos?
No. Prehensile tails, they occur... I guess there are some lizards and other reptiles that have prehensile tails, and a lot of mammals that do too. Dinosaur tails don't seem to be like that. They didn't really have the same kind of muscles that you would need for that. The vertebrae look different from, say, a chameleon's tail or a spider monkey's tail. Their vertebrae tend to be much more similar to each other. They have kind of uniform-looking vertebrae. Not really the case with dinosaurs. Yeah.
Claire Burr just gifted 10 gifts.
Holy cow, Claire! Thank you so much. Really appreciate that. Claire, your support for this community is incredible, and I want you to know how much I appreciate you. We would not be able to do a road trip like this if it were not for your support and the support of other people who've been contributing, so thank you. And everybody else who just received a gift sub from Claire, please let her know how grateful you are. And, I mean, people who contribute, they're making all this possible, so, so please thank them too. You know that we are grateful. But, everybody else, if you wouldn't mind saying thank you.
Nice to get some hype up in chat for sure.
Seriously, yeah.
And thanks, Claire, for everything that you do.
Seriously, yeah.
Question: Is it common practice? It was common practice to fake stories to fill museums when Pompeii was uncovered. Did anything like that happen and then have to be corrected for by paleontology, or is that more confined to anthropologists?
That is a great question. Who asked that?
That's another newbie.
Fatagan? Yeah. Fatagan, I've seen you here before. That is a great question. Not so much faking stuff. It's funny, the further you get away from human remains, the fewer stories you have of stuff being faked. There's some early human ancestors was it Nebraska Man and Piltdown Man. Both of those were either mistaken identities or hoaxes. And Piltdown Man, in that case, it was actually a hoax. With dinosaurs, though, it's usually more complicated than that, and with a lot of these dinosaur skeletons in early museums back during the early days of dinosaur paleontology, sometimes paleontologists or museum workers would assemble multiple dinosaur skeletons into one in order to make a complete skeleton as a big showpiece. We'll actually see. I'll discuss that a little bit when we get inside the museum, because the big Diplodocus that happened to Dippy the Diplodocus. I'm so excited to show you Dippy. It's really, really important dinosaur to not just the science of paleontology, but also to the public's perception of dinosaurs. And there are a few cases of things like Archaeoraptor that was a hoax, but that was some Chinese farmers trying to get more money by assembling different parts of different bird-like dinosaurs into a complete piece that would sell for a lot more. It's just people trying to put money on the table in that case, and some paleontologists and other folks who are a little bit too credulous about it. But yeah, outright hoaxes, stuff done with malice or with the intent to deceive, it's pretty rare in paleontology. Yeah. Hope that's a good answer.
Ios is here.
Oh, hey there, Ios.
Hi.
How you doing?
Hi, Ios.
Hope you're having a great day, Ios. It is great to have you here. We've seen most of the stuff in the sculpture garden. Actually, Lord, if you want to hang out here in the shade, I might go look at that Protoceratops real quick. Okay. It is getting hot out here. It's probably close to 90 now, if not hotter. And I gotta go in pretty soon before my equipment overheats. But I just wanted to show you this real quick. On the shore of this little pond, we've got some Protoceratops. So these were a really, really popular dinosaur back in the early 20th century. Central Asiatic expeditions that left from New York and went to Mongolia uncovered a lot of Protoceratops, including what they thought were Protoceratops eggs at the time. It was a whole thing. They turned out not to be Protoceratops eggs. But in almost every dinosaur book produced between, like, you know, the 1920s and the 1990s, you usually had Protoceratops, like, looking after their eggs. And, like, little baby Protoceratops emerging from these eggs and that kind of thing. These are an early ceratopsian dinosaur from the late Cretaceous of Mongolia. Shows them with kind of sprawling limbs like this. A lot of early reconstructions of Protoceratops have them with kind of lizardy legs. Legs kind of going out to the sides like that. We now know these were upright walking, very graceful animals. Probably would have looked a lot more dignified in the way that they walked around. But yeah. So these are early ceratopsians. These belong to the same group as Triceratops over there. This is before they had developed, you know, those big horns or anything, but they've already got the jugals, they've already got the parrot-like beaks, they've already got those frills. Yeah, it's just a little bit later that they, this group, you know, starts sprouting horns. And there we go. Oh, look, they even had a little nest here originally. I guess they took that out because those turned out not to be Protoceratops eggs. Well, cool. I love this little pond here, too. This is really neat. Apparently, there's an endangered species in here. In the museum pond are 2 of the 4 species of endangered fish native to the Green and Colorado River drainages. Wow. Pretty cool. The bony tail and razorback sucker. I wish this pond were a little bit less opaque so that we could actually see them. But, yeah. Interesting. They're clearly, like, dyeing this green. I think they... Maybe to make it a little bit cooler for the fish. You don't have as much UV going through or something. Yeah, see that green dye in there? I presume that's what that is. It doesn't look like a natural algae kind of color. Alright, Laurdee, you ready?
Yeah.
Let's walk past our dueling dinosaurs again. How tall that Tyrannosaurus is. It's funny how Tyrannosaurus has gotten shorter over time, now that it's horizontal rather than vertical. But yeah. Arms are way too big, too. Really everything about it's too big. But I remember I was here in Vernal a few weeks ago, and I was walking around at night, and all these sculptures are lit up at night, which is really cool. And you could see them from the street. It's pretty special. I'm so glad I get to stream this museum for you now, too, because last time I was here was just a couple days after my encoder died. And so some of you were here for the hotel stream, where I took a bunch of... Well, I tried to take a bunch of video, like pre-recorded video, so I could play it for you during the hotel stream. And it didn't work. Because the internet was too slow here, and the videos would not upload off my phone to the computer fast enough. So now we're back, and we're doing an actual live stream, which is super cool.
I think Nana Tyrannus says hi and wants to know where you are.
Oh, hey, Nana Tyrannus, how you doing? It's good to see you, Nana. I hope you had a great birthday yesterday. And we're in Vernal, Utah right now, at the Utah Fieldhouse Museum. We're about to go inside, where the air conditioning is. You know, Laurdee's excited about that.
Yeah, yeah.
And it's hot out here. And yeah. So I think we'll go up this way.
She didn't want to know where you were.
Oh, where's my hat? Oh, it's in the car. I don't know. We're going inside in a minute. I put sunscreen on. There's the main drag here in Vernal. See, Dinosaur Museum. The lovely Bob Walters painting up there. Allosaurus and... Is it supposed to be Camptosaurus or Dryosaurus? Probably Camptosaurus.
Thanks so much, Teacher Danny. Gabriel and his sister are loving this.
Hey, Gabriel, how you doing? Good to see you. Gabriel, one of my students from this here.
Oh, how nice.
Super awesome. Hey, Gabriel and sister, hope you're having a great day. Yeah.
Welcome, welcome.
We are going to go on a tour of the inside of the museum now. So I'm excited to have some air conditioning, maybe get some water too. Lovely.
Water bottle.
You've got a water bottle too? All right.
We
Nice and cool.
Monsters. We came here to
Oh,
find
I'm
fossils.
super excited to show you this in a little bit. We might save that for the end of the tour. Maybe we'll do it at the right now, and we'll do it at the end. I don't know. No, we'll save Dippy for the end of the tour, I think. Yeah. But this is this world famous Diplodocus skeleton. I will tell you at the end of the tour why this is so important, and we'll go take a walk underneath it. But yeah, really, really cool. This was like, for most people around the world, in the early 20th century, this was their first picture of what a dinosaur was. I'll tell you why in a little bit. The drinking fountain's over there. Maybe we'll go get some water. Or I could just, yeah. You want to hold the camera real quick? Okay. Thanks.
Hey everybody. It's been so nice hanging out with you guys. We've really been enjoying this stream. We've been enjoying doing the museums, hanging out with you guys all this time. It's been really, really fun. I hope that you guys have been enjoying yourselves as well. Danny, do most dino paleontologists know the illustrators by name and have favorite dino illustrators?
Probably, yeah. Yeah, paleo art is one of those like pretty small fields, or at least it used to be. There are a lot of younger paleo artists, especially online in places like DeviantArt. But there's probably fewer than like 50 really prominent professional paleo artists in the world, and I think a lot of people have some favorites. Yeah, I certainly do. Yeah, and I'm not nearly as up to date or as, I don't know, I probably couldn't name as many paleo artists as a lot of other professional paleontologists could, Yeah. Anyway, I do some illustrations myself too, so yeah. Anyway, let's go ahead and go on through here. We're kind of going to be going at this, I guess you can go through this whole exhibit hall one of two ways. We're going to go through it this way. We're going to go chronologically and then reverse chronologically. It'll make sense in a minute. But right here, we've got these little alcoves along this hallway, and this is really neat. So this talks about all of the different rocks and their different ages here in the state of Utah. So, Rocks, Time, and the Scenic Byway. This exhibit, Rocks and Time, follows the geologic history of the region as you see it from the Flaming Gorge / Uintas National Scenic Byway along U.S. Highway 191. So there's Dinosaur National Monument, where we are going tomorrow. Very excited about that. Here is where we are, in Vernal, Utah. And I guess we are going this way, actually from here to here. So we start off in the Precambrian era. We talked about this a little bit yesterday. From 545 million years ago to 4.5 billion years ago. The Precambrian is by far the longest of these different eras. We've got some really cool rock samples from here. Not a lot of fossils from the Precambrian, but these are all from places nearby. These are from Duquesne County. Laurdee and I just drove through Duquesne County on the way here. I think that may be where we stopped for gas in Duquesne.
I think it was.
Yeah. All of these different types of rocks. It's Precambrian rocks. They're often like metamorphosed and crunched and folded and twisted because they've been around for so long. They've had a long time for geologic forces to work on them and mess them all up. So they can be, I don't know, the geologists who work on Precambrian stuff have to be pretty imaginative, and they have to be really good detectives. So it's pretty cool. I like the three big ideas here. This is like almost like an abstract in a research paper. The Precambrian era spans 86%
What?
of Earth's history.
What?
The first billion years are very volatile, rains for millions of years, bombarding meteors, little oxygen, and no life. And the earliest signs of life are from 3.8 billion years ago. You know, give or take a few million years. Few hundreds of millions of years ago. Fossils found from this area are mostly of microscopic bacteria and algae. So life starts off very simple, very, to use a loaded term, very primitive, but it gets more complex from there. Yeah. That's funny. When you get back this far, 3.8 billion years, I wonder, we probably have more precise dates than that now. But 3.8 billion is, yeah. Again, what's a couple hundred million years between friends?
How would you even find fossils of microscopic bacteria?
Well, you find microscopic bacterial fossils. Yeah, or you might find, like in the rocks, there might be chemical traces of these creatures. Like, it's clear that the sediment that later became the rock, if it's sedimentary rock, was kind of worked on by these bacteria. You'll find like organic traces in it. So yeah. We are now in the Paleozoic era. This has a lot more fossils. From 251 million years ago, that's the end of the Permian, to 545 million years ago. So Paleozoic, that word means ancient life. This is before the dinosaurs. We've got lots of trilobites here. A trove of trilobites, as the sign says. We've got some cool mollusks. We've got bark from a big lepidodendron tree. And an eocrinoid. We still have crinoids today. They're often called sea lilies. They're these, they're related to like anemones related to urchins and sand dollars and stuff. They're echinoderms. And their fossils are pretty common in Paleozoic rocks. They were a lot more common back then than they are today. Look at all of these. Just really, really cool examples. All local. All of these look like they're from Utah. These beautiful trilobites. Different rock samples. We have a trace fossil up there. It's probably the remains of a burrow of some kind of invertebrate animal. Trace fossils they're different from body fossils. So body fossils are a fossil of somebody's body. Could be a shell, could be bones, could be something like that. Trace fossils are things like footprints or droppings, like fossilized dung, coprolites, fossil poop. They could be like scour marks or like trails with limbless animals like going through the mud, that kind of thing. Those are trace fossils. Trace fossils are super important because they actually show you the activity of an animal that was once alive, preserved in the rock record. Anyway, lots of other really cool invertebrates. Crinoids, bryozoans, sponges. Cool stuff.
Can you get up close to this and show the texture of the coral?
Oh yeah, this is really neat. Ancient corals right here. These look like horn coral. That's probably what they are. Just beautiful. Really neat. Yeah, and those are from the Pennsylvanian period, so they're that's not right. It says 250 MYA. 250 million years ago is like the beginning of the Triassic. It should probably be 350. Yeah. It's funny that they'd make an error like that. This is such a well put together museum, and like find a goof like that, a typo, because this stuff is really well done, clearly written by some people who really know the local geology. So if you live here in Utah, I'm sure this is a lot more meaningful to you, talking about the different places where you can see these age rocks. I wish we had something like this in the Bay Area.
Yeah.
But we don't, to my knowledge. Like public exhibits that really focus on the geology and they try and make it relatable to people, who live in those places today. I see something like this along National Scenic Byway US 191, like, oh, okay, cool. But if it were a road that I travel all the time or something that's near my home, suddenly it's that much more relevant, I wish we had something this wonderful here in the Bay Area. Anyway, Paleozoic era at a glance begins with the Cambrian explosion. This is when life, at least life with hard parts that easily fossilize, really takes off. Animals and plants move out of the sea and onto the land. And then the largest mass extinction in Earth's history, the end Permian extinction, ends the Paleozoic era. So over 90% of all species on Earth died out. It's kind of the mass extinction that paves the way for the dinosaurs. And over here, this is a wonderful cross-section of this area here, I think Uinta County in Utah, showing these different geologic formations here. Here's that Permian extinction, where over 90% of all life on Earth died out. Right there. And then after this, Moenkopi Formation is like early Jurassic, or no. I thought it was early, maybe it's Triassic. Chinle Formation is Triassic. Navajo Sandstone is early Jurassic, and then we get into the late Jurassic here in the Morrison Formation with world-famous dinosaur fossils. We will be seeing some prime examples of those tomorrow at Dinosaur National Monument. And here we've arrived in the Mesozoic era, from 251 to 66 million years ago. It says 65 right there, I know, but we've since refined those dates. We now know it's 66.
Kleber gifted Arrogent Logician a subscription. Kleber gifted a tier 1 sub to Arrogent
There's our
Logician.
Utah Raptor that we saw
We
earlier.
have given 45 gift
We
subs
are
in
now
the channel.
inside in lovely air conditioning, safe from Utah Raptor.
These are the tracks.
Yeah. It's a big old theropod track right there. Big old tridactyl dinosaur footprint.
So when someone takes a track,
Uh-huh.
do they leave it in the ground and fill it with?
Sometimes. It depends. So in a case like this might be just a cast of a track, where like the actual track is a depression in the ground.
Somewhere, yeah.
But sometimes we actually find tracks where they're positive like this, where it's just like a blob on the surface.
Huh.
Yeah, I don't know enough about dinosaur tracks and how they're formed and that kind of thing, but sometimes you do just find a block on the surface. Like I think this is one of those right here. This one right here. Where like the original track got filled in with mud. So like, you know, when an animal leaves a footprint in the ground, that's a negative space. Then other material fills that in. Mm-hmm. But sometimes that material is harder than the mud that was underneath it.
Right.
And so that's the part that survives. And that might be the case with this right here.
Claire just gifted a sub to Arrogent Logician.
Oh, thank you so much, Claire. Yeah, I appreciate that. Arrogent, I hope you appreciate that too. Yeah. Very cool. Big bayoneted turtle right here. Turtle shell. You can see this is the front. This is where its head would come out. And there's the back of the turtle. Pretty cool. And lots of really neat dinosaur tracks. These don't look like dinosaur tracks, actually. What are these from? They're from a phytosaur. That makes sense. Phytosaurs were these early... They kind of look like... They look a lot like crocodiles, but they're not crocodiles. They're kind of crocodiles before there were crocodiles. More awesome dinosaur tracks. Oops. It's my microphone. Trying to escape there. Very cool. And lots of examples, not just of different rocks, but different fossils. There's a lovely ammonite right there. From the Mesozoic. And here, just look at this. The Morrison Formation. This is what we're going to be looking at tomorrow at Dinosaur National Monument. These are some of your favorite dinosaurs are from the Morrison. Allosaurus, Stegosaurus, Diplodocus, Camarasaurus, and Dryosaurus. All from the Morrison Formation. Very cool. And this is Frontier Formation. I've also worked in a formation called the Frontier. I wonder if it's the same one. I dug up dinosaur tracks in the Frontier Formation of Montana, right on the Montana-Idaho border. I wonder if it's the same Frontier Formation from here. It would be Cretaceous, so that sounds right.
Yeah, that's my question.
Yeah, I don't know.
Claire wants a throwback to the moss chops. Is it a therapsid or synapsid?
That's a great question. I think it's a therapsid, but I'm not positive. You can look it up. It's some kind of dinocephalian, I think, which I think are therapsids. Yeah. Anyway. Yeah. I like this. If you were standing here during the Mesozoic, you would be underwater. If you swam to shore, you would find the land was ruled by dinosaurs. It all ends with a bang during the KT extinction. We now call it the KPG extinction, but that's neither here nor there. That's when dinosaurs and 2/3 of all species on Earth became extinct at the end of the Mesozoic era. Yeah, pretty neat. And these are 3 dinosaurs that we'll actually see on this tour: Stegosaurus, Allosaurus, and Diplodocus. Cool. Well, let's go ahead and keep on going. So the non-avian dinosaurs have just gone extinct, and here we are in the Cenozoic era, the age of mammals, from 66 million years ago until the present. And so, there's our mammoth over there again. Which is appropriate. Mammoths are from the Cenozoic era. We are currently in the Cenozoic era, by the way. It says a vernal mammoth. This sculpture was made in the early 1970s and joined the dinosaur garden in 1978. Its fur is made of hemp. That's why it's so durable, I guess. And we often replace it because birds like to make nests with it. That is so funny. I would love to see some birds, probably magpies, coming over
Really
here.
spectacular.
Pulling the fur out of this mammoth to go make
Clever
nests with
gifted
it.
Moosey Fate 1 a subscription. Clever gifted a tier 1 sub to
Mammoths lived in
Moosey
this
Fate
region during
1.
the Pleistocene, when it was
They
much
have
cooler
given
here.
46 gift
10,000 to 2
subs in the
million years ago.
channel.
Yeah. Pretty cool. Mammoth sculpture by Albert H. Porter. And there it is on the back of a truck. It's being brought here back in the 70s. Pretty neat. Thank you, Claire. Really appreciate that. That's awesome. Moosey Fate, you enjoy that sub. Yeah, well deserved. Well deserved.
Hey, I've heard that it is a hoax that dragonflies were 3 feet long during dinosaur age. Any thoughts on those possible fossils?
It's not a hoax. It's just that it was before the dinosaurs, and maybe not 3 feet, but like maybe 3 feet long. I don't know. They had like a 2-foot wingspan during the Carboniferous period. So this is like 350 million years ago. There were dragonflies that were very, very big, like the size of a raven or something like that. This is when oxygen levels were higher. And, you know, plants were huge at the time, and like all kinds of arthropods, you know, like insects and their relatives could get really, really big. Insects and their relatives have kind of an inefficient respiratory system. So they can't get super big unless there's a ton of oxygen. And there was a ton of oxygen back then. If you want more information about this, you could Google Meganuera, or look it up on Wikipedia. Meganuera is a giant, it's not a true dragonfly, but it's like a dragonfly relative. And they got to have like 24-inch wingspans, something like that. Really big, like approaching 1 meter. Pretty cool. Anyway, back to the Cenozoic era, the age of mammals. This is a cast of Protoceratops. This is an early horse. I think from the Green River Formation? Yeah, Green River Formation of Wyoming. Not too far from here. So horses started off very, very small. About this size. About the size of a Cocker Spaniel dog. And they had not just one hoof, but multiple little toes there. These guys have 3, I think. And we will see some models of these as we go through the next hall, all fleshed out. There's these beautiful fishes here. The Green River Formation is famous for these fossil fishes. But occasionally, in looking through these sediments, you also get really lucky and find land animals in there too. Like this early horse. This is from about 50 million years ago, give or take a few. So, you know, like about 15 million years after the dinosaurs go extinct, mammals start finally doing something interesting, turning into horses and primates and stuff like that. Yeah. Yeah. Over here, we've got an alligator head. And an ancient crocodilomorph. Oh, apparently it's genus Crocodilus. It's the same genus as the modern Nile crocodile. It's a lovely fossil from the Uinta Formation right here in Uinta County, Utah. Really neat. I don't know, crocodilians, they have all kinds of amazing shapes and sizes and stuff over Earth history, but the ones that stay in the water and kind of do your, like, alligator type gig, they typically, they don't really change all that much superficially. And if you were to go back in time, 150 million years to the late Jurassic, and you were to see some crocodilians, you would be able to recognize them just at a glance like that. They would look pretty much just like modern crocodiles, which is kind of cool. Evolution is one of those interesting things where, like, if the environment is constantly changing and you have to, like, reinvent yourself, then you can change a lot. But if you're kind of in the same spot, doing the same job for a long time, you don't really have to change that much. At least, your genes are always changing a little bit. Things are always shifting around a little bit. That's just like background noise, background change. But you could basically be an alligator for, like, 150 million years as long as you have the habitat to do it in, I hope this is making some kind of sense. Yeah.
Sugar brings up a good point. Compared to there's a lot of real fossils here.
Yeah,
compared
absolutely.
to yesterday's museum.
For sure, yeah. A lot of these are real. Like, here's I think this is a Gomphothere femur right here.
That's amazing.
Isn't that cool?
Yeah, and I love, again, I love the hands-on exhibits.
Yeah.
I just love that they do this down at, like, children's height and stuff. It's just really great.
Super cool. Yeah, I love museums where they put things out where you can actually touch them, It's great to look at things at museums, but to have that personal connection where you can actually, like, reach out and put your hand on something that's tens of millions of years old, that's a really neat kind of connection to make. I really appreciate that, and I know a lot of viewers do. I'm glad you do too, Laurdee. Yeah. So again, this is after the dinosaurs go extinct. Mammals finally take off. They go from being tiny, shrew-like creatures living in the shadow of the dinosaurs, like they had been for 150 million years, to achieving all kinds of great big shapes and sizes and diversifying and doing all kinds of cool stuff. There's a saber-toothed cat. That's a cast up there. It's not a real fossil. But these other ones are real. You can even see some bits of lichen growing on the teeth there, it looks like, from when this was first collected. Cool stuff. Here's some awesome rocks from different parts of Utah. We drove through some of these formations on the way over. I recognized that conglomerate. Yeah. There's a fossil snail, 41 million years old. Right there.
It's amazing how shells fossilize and look perfect.
Yeah.
Like bones fossilize and they, like, get broken and chipped and stuff, but it's like I've seen some shells that, like, just look like perfect stone representations of, like, that crab we saw.
Even just, like, the finest details preserved. Yeah. Shells are particularly easy to fossilize.
Right.
Yeah. They almost come kind of pre-fossilized if you think about it, as the animal kind of extrudes them and grows them over the course of its life. Look at that. This must be related to obsidian right there. This really, really shiny mineral there. Gilsonite is what they're calling it in the sign. It's like volcanic glass. This is when, so like obsidian forms when lava cools very, very slowly. So like all of those air bubbles have a chance to work their way out as it cools, and it becomes smooth and glassy. And other volcanic rocks like pumice, or like, lava rock that you might have in your garden, that's when it cools really, really quickly. Do I have this right? I think I have this right. And like all the bubbles just pop. Yeah. So it leaves that really kind of like pockmarked, like spongy sort of texture. Yeah.
Just Beth asks, were the mammals able to evolve because the dinos were gone?
Yes, that's what we think at least. Because, mammals and dinosaurs evolved at basically the same time. So for the entire age of dinosaurs, there were mammals walking around doing their mammal thing, but they were all super tiny. again, like I said, living in the shadow of the dinosaurs. It's not until that asteroid strikes and just changes everything. Basically all big animals on Earth died out. And mammals kind of exploited that absence of the bigger animals. And they diversify and get big after that. So yeah, it was a case of the meek inheriting the Earth. Maybe the best case of that there's ever been. Most exemplary case, yeah.
Is lava rock manufactured, or do you think is actually harvested from volcanoes?
It's probably harvested, yeah. I mean, there's enough areas that have volcanic deposits like that I think it'd be more expensive to like manufacture it in a lab or something. Yeah.
Just curious.
I think so. When we were driving through Utah to get down to, or driving through Idaho to get down to Utah, we were going through the Snake River Plain with all those weird blocky volcanic rocks.
Yeah.
There's, I'm sure, a ton of lava rock in there, just everywhere. There's whole landscapes made out of this stuff. Yeah. You know, we drove through this today, the Duquesne River Formation from the Eocene. Pretty neat. Pretty neat. All right. Let's continue on through here. Rocks and Time Hole. I think that's what we just saw. We're going to go through here. So. Here, hang on. Bear with us here. We have now traveled back in time to the Eocene epoch in the Paleogene period. This is not too long after the non-avian dinosaurs go extinct, and mammals are really starting to feel themselves, really start to get big and start to exploit some of those ecosystems. And this is a time when Earth's temperatures were really, really high. The Paleocene-Eocene thermal maximum, or PETM, is a time when there were like palm trees way up on the north slope of Alaska. Tropical environments at really high latitudes. I've got all kinds of cool mammals and also reptiles like this monitor lizard up here. Oops. Someone's keep slipping. Microphone. Monitor lizard, these tropical plants, cattails, palms. Yeah, we're going to go see some more of those mammals in just a minute. What were you asking, Laurdee?
How were the mammals able to survive the dinosaur extinction?
Probably because they were small. I mean, so when that asteroid hit, basically every big animal on Earth died out. We're not entirely sure about all the mechanisms of extinction, like why certain animals went extinct and other ones survived, but the pattern is, if you're a small animal at the time, you probably survive. If you're anything above like 20 pounds, you go extinct. So, yeah. Anyway, this is pretty cool. I like that we're going through this backwards. This is, did you find them all? We're going to try to. All these different creatures. Uintatheres, primates, Pteranodons, artiodactyls, snakes, turtles, dragonflies, a varanid lizard. We already saw that one right there. Duck-billed wading bird, frigate bird, pond turtle. And then here's all these different plants, too. Can't forget about the plants. Sumacs, sycamores, palms, lotus, legumes. Extinct chocolate family plant. Ferns, monocots, ear plants, elm trees, poplar trees, willows, epiphytic ferns. See many of those you can spot as we walk through here. Some ferns there. There's our monitor lizard. Some turtles over there on the painting. There's a turtle right there. There's some sort of little artiodactyl there, like a little ancient horse relative or something. I love the dappled pattern on it, all those little spots, like you might see on a baby deer. It's so quiet here. They really ought to pipe in some sound for this, like be a little bit more immersive.
Just a little bit, yeah.
And here's those big Uintatheres. These guys might look like a rhinoceros or something like that. They're not. I forget what these guys are related to. But this is a group that just goes completely extinct. We don't have any representatives of these guys today. It's so early on in the age of mammals. that many of these groups just aren't around anymore. Like this guy over here. This is what a Pteranodon, I think. Yeah, what a weird creature. Close up on the face there. It's just bizarre. Presumably an animal that was at least partly carnivorous. There's our frigate bird up there. And where is that little marsupial, or that little mammal hiding? The little primate. There it is. Reminds me of like a bush baby. He does not look happy to see you, Chad. I'm sorry. What are you doing scaring the marsupial, or scaring the primates, chat? Yeah, pretty cool, pretty cool. And we'll see some fossils of these critters over here. I think these are all from I want to say these are Green River. Also, all of these, each one of these slabs has a beautiful fossil leaf on it. Some of them multiple fossil leaves. And leaves and other plant fossils are extraordinarily important for helping us figure out what ancient climates were like, and what was the annual rainfall back then, and average temperature, that kind of thing. The plants show us what these environments were like. Really cool. And so using this kind of information, you can build a diorama like that and try and show what that ancient world looked like.
Really spectacular, spared no expense.
Super cool.
Kleber gifted Conqueror a subscription. Kleber gifted a tier 1 sub to Conquer. They have given 47 gift subs in the channel.
Very cool. This is related to beans. That's a legume seed pod right there. An elm. Benzoin tree, twining fern, a poplar, all kinds of cool stuff like that. Do we have any plant fans here in the chat? Anybody particularly interested in botany? You're probably really enjoying this. This is so cool. Extinct soapberry tree. Yeah, I've never found many fossil leaves in the field because I've never really cracked many rocks open like this. This is how you do that. Just crack the slabs open, and usually, if you do it right, they fracture along the same plane that the leaves are on. The leaves kind of form like a weak spot in there, and so when you crack it open, the leaves are just there peering out at you. Pretty neat. That's how it's supposed to work. Over here we've got some of these other animals, some of these animals that shared this environment. Some crocodilians up here. To some lovely turtles. Hey turtles. Tons of turtles, so says the sign. Look at that, it's beautiful. Just this big shield right here. Raindrop turtle shell. Apollone species. Huh. Really, really flat turtle. This almost looks like a plastron rather than a carapace, but I think this is a carapace here. The carapace is the round one on top. The plastron is like the chest plate underneath. It's usually flat. I think this is a carapace. It's just a very flat one. Although I could definitely be wrong. Again, I'm not a turtle researcher. And I've got some lovely vertebrate animals here and traces of them too. Beautiful fish skeleton. Look at some of these.
Danny, where would you say is the best place in the world to crack open shale looking for fossils?
It depends what kind of fossils you're after, yeah. If you're looking for, feathered dinosaurs, Liaoning in China. If you're looking for the first birds, Solnhofen in Germany, in Bavaria. If you're looking for, Jurassic Age stuff, you could look in the limestones of the cliffs of, like Dorset in England, the Jurassic coast. Depends what you're after, If you're looking for fossil fishes, And Green River, Wyoming is probably your best bet. Yeah. All depends what you're looking for. Here's a
Really
cast of a lovely
spectacular.
bird.
Spared no expense.
Clayburg gifted Sofluff a subscription.
Linuloides,
Clayburg gifted a tier 1 sub to
That means like
Sofluff.
chicken form.
They
I
have
guess.
given 48 gift
Recognize
subs
the
in the
root word
channel.
there, Gallus. Pretty cool. Fantastic flowers. Oh, fossil flower. Those are pretty rare. So that is super cool to see. Yeah, and this is what Earth's continents looked like during the Eocene. This seaway that used to be in the middle of North America during the Cretaceous had dried up by this point. And yeah, there's some big old lakes back there. Fossil Lake, Uinta Lake, and Gashiote Lake. I don't know if I'm saying that correct. But it's cool that we have this much information about the ancient geography that we can even go naming lakes that no longer exist. It's pretty neat. Lakes from 50 million years ago. There's some reconstructions of these animals that lived at the time during the Eocene. Pretty cool. I've got some beautiful fossils of all these critters. Take a look at these. All this mammal stuff. Look at this. It's like a dorsal vert right there. Look at that knurl spine on it. Super long. That's from a brontothere. These guys, just like bison, probably had really, really tall withers. Like the area of their spine, kind of between the shoulders, is really high. Think of it kind of like the Golden Gate Bridge. You've got these tall towers with tendons that go down either side to help support stuff hanging off of either end, like the head and neck. Pretty neat. Went to their jaw fragments. Here's a fragment of a primitive horse's lower jaw. It's a mandible right there. Look how small it is. Look how small it is. You'd be hard pressed to find an adult horse jaw that small today. Super cool. And these are all from the surrounding area. Most of these seem to be from Utah. There's a few from Wyoming too. Many of these are from the Uinta Basin. So from right
Really
near here in
spectacular.
Vernal.
Spared no expense.
Clayburg gifted
Check
Tofi
out
Bites a subscription.
These
Clayburg
weird
gifted a
and
tier 1
wonderful
sub to
big old
Tofi
mammals.
Bites. They have given 49 gift subs in the
Brontotheres.
channel.
There's a tapir-like animal. Just bizarre. Look at that one. Look at the teeth on that. I don't know very much about these. I'm not a mammal guy, and so I'm kind of relegated to just pointing and going, ooh, look at that one. But these are super cool.
Did you ever work with modelers that interpreted skin on fossil skeletons?
Not like directly, but I've done some of that
Really
myself.
spectacular.
Yeah,
Spared no
yeah,
expense.
like
Clayburg gifted
illustrating
Pup Time a
extinct animals.
subscription.
Done some of that.
Clayburg gifted a tier
Some
1 sub
speculative
to Pup
skin work
Time.
before.
They have given 50 gift subs in the channel.
That was the weirdo critter with the derpy face we saw earlier. Stylinodon. Let's see. Oh, and this is a type specimen for Stylinodon. Super cool. That one right there, I guess. So a type specimen is like, this is one of the references for this genus. So like if anybody comes to the museum and they're like, I want to see some Stylinodon stuff, I think I might have a Stylinodon at my museum. You would look at the type specimens like this right here. This is kind of what this genus was named based off of. That's super cool. Yeah, it's a Taniodont, which is some kind of weirdo, maybe semi-carnivorous mammal. It's got big old claws on it. I bet you it was fossorial. I bet you it did a lot of digging. And then check out that brontothere up there. All those big knobby things on the front of his head. Man, mammal skulls are so weird. I'm so used to dinosaur skulls that these are just bizarre. I think that these animals lived right here not that long ago. In the grand scheme of things, 50 million years ago was not that long. And then we have this wonderful Uintathere right here. Oh, that's beautiful. Look at that. So I think this is a cast, although this is clearly a very old mount. You just look at all of like the metalwork on there. This was done a long time ago. This might be one of the oldest specimens in this museum. And back in the day, it was not uncommon to actually mount real fossil skeletons like that, and sometimes just jam the metal support straight through the bone. So this could be one of those examples. It was also not uncommon to paint over the fossil bone so that everything's nice and uniform in color to make it prettier. But I bet you this is a cast. It's so cool though. Just trying to give you a different view along here. Really neat. Really neat. Is Alex's mammal skulls feel more dense than dino skulls? Absolutely, yeah. Yeah, I mean, look at this. Just by way of example. Dolucarinus. That's the genus name of this creature, apparently. And these are the real fossils there. You see the specimen numbers painted on them? Those little white labels? Yeah. What a weird looking skull.
Really spectacular.
Mammal
Spared no
skeletons do
expense.
usually seem more
Clever
robust than
gifted
dinosaur
Zal 0K
skeletons. They're kind of,
subscription. Clever gifted
from
a
the
tier
perspective
1
of
sub
somebody who
to
works
Zal
on
0K.
dinosaurs, they're like
They
needlessly
have given
dense
51 gift subs in
and
the
heavy.
channel.
Yeah. Very cool. So this is Uintatherium right here. Oh, paper mache skeleton, it says. Well, there we go. Okay. It's made of paper mache.
Now we know. Now we know.
Now we know. Yeah, so these are the same critters that we saw back in there. This is a skeleton of those guys in there. Uintatherium. Let's get another close-up of these. Weird. And so this is an animal that had these big, like, saber canines on it. But it's a plant eater. Maybe it used those for defense amongst each other. The way they're portrayed right here, they almost look kind of like hippos. Hippos have some big, gnarly teeth on them, despite being mostly plant-eating animals. I've heard hippos will occasionally eat meat, just like kind of for fun. Maybe these guys are the same. They just kind of eat whatever they want. Most of the time, plants are easiest, but yeah.
A couple things.
Yeah.
D. Stouffer, who I think might be new,
Yeah.
said surprising it doesn't say whether or not it is real or a cast.
Oh, yeah. I mean, I just wasn't looking closely enough, but it says paper mache skeleton.
And then
I'm going to adjust the camera real quick. Let's see if I can straighten this out a little.
can you actually keep fossils if you find them?
It depends where you find them and who owns the land and what kind of fossils they are. Here in the United States, we have really loose fossil laws for the most part. Even if you find a super important fossil on private land, then it belongs to the landowner. Doesn't matter how scientifically important, it belongs to the landowner. Other countries have more sensible fossil laws where, like, fossils are considered part of your collective natural heritage in that country. So they belong to the people. They belong in a museum. On the US, if you find fossils on public land, then they do belong to the people. So if you're on BLM land, Bureau of Land Management land, if you're on other federal lands, if you're on national park land, those fossils should be collected by professionals and reposited in a museum. For vertebrate fossils, at least. Sometimes if you find clams or lobsters or ammonites, stuff like that, then the rules don't really apply. Then you can actually keep them. Because there's usually so many of those that, it's cool for people to be able to collect stuff like that and have a collection at home. Yeah. So, yeah. You found coral on the beach. Very cool, Enlightened Library. Coral is super neat, yeah. Was it fossil coral or was it modern coral? But it's cool to be able to have something like that, be able to keep it. It's kind of a connection you're making with nature, That stuff is important. It really is.
Are there some dinosaurs that only make eaters with gnarly teeth, just like rhinos?
I guess so. Just like what?
With gnarly teeth like rhinos.
Like rhinos. Rhinos don't have gnarly teeth. Yeah, rhinos have...
That was the question.
Yeah, they've got pretty... Maybe you're thinking of hippos, but yeah, rhinos have pretty pedestrian-looking grinding molars. But yeah, no, certainly panda bears have pretty gnarly-looking canines, which they use for defense and stuff. Yeah, there are some plant-eating animals that are descended from meat eaters. Pandas are actually a great example of that, where their ancestors ate meat, and then they switched to eating plants, and their teeth haven't fully made the adjustment yet. Yeah. Hippos are another good example. Yeah, they got those giant canines on them. Anyway, I wanted to show you this too. We saw this guy over in the last room. This is an artiodactyl, an even-hoofed mammal. So it's a mammal with an even number of hoofs. Horses are perissodactyls, actually. They've got one. Related to like deer, camels, and stuff like that as an artiodactyl. Very, very cool. And these look like the actual fossil bones. It's really strange that they would be put into a display like this. This must be from a long time ago, like the early 1900s maybe, or even older. Put into a display like this. Normally, when we have important fossils like this, when we have the real bones, we want to keep them all separate from each other, like not stuck together like this. We want to have them in separate pieces so that they can be individually studied and turned over and photographed and measured and all that good stuff. But back in the day, I think a lot of people were more focused on just creating really beautiful museum specimens like this, which, fair enough. That's cool. Hopefully we found good specimens of that animal since then. Pretty cool. This is pretty neat. Wow, I didn't look at this the last time. Native Eocene mammals past and present. So, we've got the past in this row up here, and then the present. And we can see which of these animals are no longer around today. They've gone completely extinct, like Taniodonts, rooting beaver-like animals. Creodonts, also extinct. Carnivores hadn't evolved yet. Small lemur-like animals evolved into things like us here now. Dinoceratids, like these euanthotheres, are extinct. Artiodactyls, still around now. It's like that little guy that we just took a look at a minute ago. Mesonychids, extinct. Condylarths, extinct. Perissodactyls, odd-toed ungulates, still around. Bats, still around. Opossums. I guess we don't have opossums here in Utah now. It's probably too cold for them. And insectivores, still around now. Pretty cool. So, it's interesting how during the Eocene, some things look very similar to today, but some things were very different too. This is still very early on in the age of mammals. I don't know, Laurdee, have you had about enough of the mammals? Ready to see some dinosaurs?
Yes, I was afraid to ask if we were not going to see any more dinosaurs, because I was worried that we weren't going to see any more.
No, I decided we would save the dinosaurs for last.
And I'm a little bit confused about this as well. Paramedics Underground says, did you say carnivores hadn't evolved yet? Expand on that, please.
Oh, yeah, sorry, that's a little bit confusing. Carnivorine mammals. So carnivore can mean meat eater. It's just kind of like a broad term. Like if you have a friend who eats a lot of meat, she might say like, oh yeah, I'm totally a carnivore. So the word has that meaning, but also carnivorins are a specific group of mammals. They include dogs and cats, and things like raccoons and weasels and skunks and badgers and hyenas and critters like that. So yeah, it should really say carnivoran, but that's like a specific group of mammals. There are lots of other mammals on here that are not carnivorins, that are carnivores. They do eat meat. Yeah. So like mesonychids might be some of the top carnivores of the time. And that's super funny. This is kind of out of date. I don't think we think mesonychids are the ancestors of today's whales anymore. They're close to them, but whales did not evolve directly from messinigids. Anyway, so carnivorans and carnivores, it gets confusing, you know? Thank you for asking for clarification there. Yeah. Meat eating is something that's existed in mammals for a super long time. There are lots of meat eating animals here in the Green River Formation, and in the Uinta Basin. But yeah. But the carnivoran mammals, dogs and cats and weasels and hyenas and stuff like that, hadn't evolved yet. Yeah. Anyway, you about done with mammals? About to move on into the age of dinosaurs here? You ready, laurdee?
Yeah.
All right, let's hit it. So, mammals diversify and flourish. We already saw this part. We're kind of moving backwards through this right now. Dinosaurs are extinct. Except for birds. No longer. We are going back in time. 100 million years past. And then here we are in the Mesozoic era. So we have gone back in time to the Jurassic period, the second period in the age of dinosaurs, with such star animals as Stegosaurus. Remember when we were outside, I told you we would see a real Stegosaurus skeleton? Or at least a cast of one? Here we go. Yeah. This animal's a little bit smaller than the one that we saw outside. But even more impressive, if you ask me. Just beautiful. I love the Jurassic Hall in here. This is so cool. Beautiful painting on here, too. This is just gorgeous. I really like it. So there's a big fleshed out Stegosaurus there. And some babies. An Allosaurus. And then that sauropod over there. Does anybody have a guess what sauropod that might be? Way back there? This is a deep cut. If anybody gets it, I would be impressed. Not one of your typical Morrison Formation sauropods. Yeah.
What is the technical term for the spiky cluster on the Stegosaurus tail?
I feel like this is a leading question. I feel like whoever asked this question already knows. Do you know what it is?
I think it's a thagomizer.
You're right, yeah.
Thagomizer,
Yeah, it started off as an informal term. There was a cartoonist, the guy who did the Far Side comics, Gary Larson, and he did a comic that talked about that, and he jokingly called it a thagomizer, after the late Thag Simmons. It's like some cavemen who were like giving a PowerPoint presentation. And like, this end we call it the thagomizer, after the late Thag Simmons. But some paleontologists actually ended up using that term, kind of as a joke, just for fun, but it's kind of caught on. And so, that cluster, that array of tail spikes on the end of a stegosaur is sometimes called the thagomizer. Just kind of a fun term. I wonder if researchers like Susie Maidmont use that, or I know that Ken Carpenter has used it in publications before. This is new. This wasn't here last time. This is pretty cool. They just needed a place to put this. This looks like a tree trunk. Yeah, very cool. Beautiful petrified wood here. Look at that. That's gorgeous. I like that a lot. This is probably en route to the prep lab, or they're just storing it here before it's brought to another museum or something. I wonder how old it is. It's a sizable chunk of wood there. And I love the danger tape. You know, caution might have been more appropriate, but you know, danger just has that drama to it. Wow, look at the sparkliness in there. Those little probably quartz crystals. Very cool. Super neat. All right. Let's look at what we've got over here. Here's a limb bone of Stegosaurus. It's just what, like a... It's not a humerus. It's an ulna or radius. Pretty cool. Oh, and here we go. I got a question about this a while ago, about the second brain in Stegosaurus's hips. Yeah. It says, can you see the large space in the Stegosaurus pelvis? This is for the sacral ganglion, an enlargement of the spinal cord paleontologists thought might be a second brain. Now we believe this nerve concentration wasn't a true brain, but it did work to provide better control to the tail and hind legs. Which is pretty neat. Stegosaurus famously has a pretty small head, and it didn't house a particularly large brain. It's got a brain about the size of a golf ball. But it's still, it's a big animal. And so, how does it control its whole body? Even just that little brain. It may have had some help by that sacral plexus, or vertebral ganglion, or whatever you want to call it. That space in between its hips where it's got this bundle of nerves. Right there. What a beautiful animal. Stegosaurus. You can see why this is many people's favorite dinosaur. I think this is Laurdee's favorite dinosaur right here, Stegosaurus. Here. Laurdee, is this your favorite dinosaur? Yeah. She's nodding her head, yeah. Now, Stegosaurus is actually really weird by stegosaur standards. Most stegosaurs don't look like Stegosaurus. There's a whole family of dinosaurs called Stegosauridae, Stegosauria, if you want to go broader beyond that. And Stegosaurus is the largest, might be the most flamboyant of all the stegosaurs. Can we get some stegosaurs going in chat, by the way? I don't know if, And Concrete says, oh cool, dinosaurs invented distributed computing. Maybe. Although invertebrates have that kind of thing. A lot of invertebrate animals, like lobsters or insects, have decentralized nervous systems. Yeah. Man, really cool animal. And right here, we have Stegosaurus in a jacket. You see this kind of whitish stuff in here? Here, look closely at that. I'll bring the camera nice and close so you can see. This is what we call a field jacket in the biz. So when we're in the field and we find a dinosaur and we want to bring it back to the laboratory, the way to do that usually is to create a field jacket. So we take burlap, this really coarse fabric that you see right here. See that fabric texture right there? And we soak that in plaster of Paris, and we make these big wet plaster bandages, really, really messy. Jacketing is always like an undertaking in the field. It's always really messy. It takes most of the afternoon if you do it thoroughly. Yeah, it can take weeks if you have a really big specimen. Anyway, we take those plaster bandages and we put them over the fossil. First, you put a separator layer underneath, usually like damp paper towels, in order to act as a protective barrier between the plaster and the actual fossil. But then you put the plaster bandages over it, then they harden, they solidify, and you end up with something that kind of resembles like a cast that you'd put on a broken arm or a broken leg. It helps hold everything in place and protects the fossil as you bring it back to the museum, back to the laboratory. And then once there, you cut it open, like you see here, and you start cleaning it. This is neat that they left it here in the jacket so you can actually see what this looks like. It gives you kind of a nice window into how we do this in the field. So you've got some ribs right there. There's the vertebral column. And that might be a scapula right there. And then is that a plate up at the top? We've got a couple of plates too. Pretty cool. Pretty cool. Let's see. That's some space ribs. What do you mean, Darkness? Funny, this is well-armored Stegosaurus. Those plates were not actually armor in like a protective sense. We think that they were for display. This would have been a very showy, very flamboyant animal. Probably very, very brightly colored on those plates. Back there, I love that painting, but it's a little dull. I mean, in terms of its coloration. This probably would have been very brightly colored animals. Yeah. So social Stegosaurus, many of the questions scientists ask are about their social lives. Do they travel in herds? How do they care for their young? We painted the Stegosaurus in the mural as a family group, but we don't know if they foraged in herds or families. What do you think, and why? Researchers look for fossils of young and adult Stegosaurs together to help find answers. I think, like most dinosaurs and like most modern birds, they probably would have been very social. Got every reason to think so. So, yeah. Yeah.
Paramedics Underground says, I've noticed that the radius and ulna bones has been present in not only ancient mammals, but also many of the prehistoric dinosaurs in the museum.
All the dinosaurs, yes.
When did paleontologists first start looking at the radius and ulna bone structure in living things?
In fishes, believe it or not. So all land-living animals with skeletons, what we call vertebrate animals, they all evolved from fishes. And fish actually have that same structure. If you look at like some of the earliest ancestors of land-living vertebrates, things like Tiktaalik, they've got that same pattern there, where they've got the humerus, upper arm bone right here, and they've got the radius and ulna in the lower arm, and then you've got the carpals and the metacarpals and the phalanges. Fish actually have that pattern in all of these animals. You know, dinosaurs, mammals, amphibians, reptiles, all of us inherited that from our fishy ancestors. That's why we all have the same bones, you know? It's pretty cool to think about. If you want to learn more about this, there's a fantastic book and a documentary series that you can find online called Your Inner Fish with Neil Shubin. Can't recommend that highly enough. It is phenomenal. Honestly, like, if you're interested in this, like, turn off this broadcast right now and go watch that, because it's great. Your Inner Fish with Neil Shubin. Fantastic stuff. But yeah.
Is the fossil completely out of the ground when you put the jacket on?
Is the fossil completely out of... No, it's not. That's a great question. Here, I'll show you. So when we're over here...
A real mean kid. With 6-inch daggers for teeth,
okay.
he was the terror of his neighborhood.
You got to flip the jacket as you're making it. This is like one of the trickiest parts. So here, what you're looking at is actually the underside of the jacket. So when we find, say you find a Stegosaurus all laid out on the ground, all flat like that, what you do first is you put a top jacket on it. So you like dig around the extent of all the bones. It's almost like you're digging a little moat or something like that around them. And then you put the jacket over the top. And then hopefully it's not super wide and you can actually kind of dig underneath and keep putting more strips underneath and underneath, kind of form like a mushroom shape. But eventually you've got to actually make the flip where you've got like the little pedestal underneath and all that stuff overhanging. Hopefully you have all of that hemmed in by layers too that you dry there. And then eventually you've got to break the pedestal, flip the thing over, and then you dig down through the rest of the... You remove as much rock as you can to make it more lightweight, make it easier to move, and then you put a bottom jacket on it. It's a very laborious process for a big dinosaur. I've done a lot of this before. When we were digging up Yoshi's trike back in 2011, big old Triceratops. The hips were all, you know, in one solid piece. We couldn't break it apart in order to move it. We had to have like a gigantic jacket. When we wanted to move it, it ended up being too heavy for the helicopter that we called. We had to call in a bigger helicopter like a month later. But anyway, when you've got a really big jacket like that, you've got a lot of overhang. So usually you have to have crew members who are lying on their backs and they are pushing up with their hands, trying to hold the plaster bandages in place while they dry. So you could be there for like an hour, just holding like this. It's like something they'd have you do at Guantanamo Bay. It can be really painful. And this whole time you're having wet plaster like dripping onto your face and into your mouth and into your eyes. And making a jacket like that can be, it's an experience for sure. We had names for this process that I can't repeat here on a family-friendly channel. But, maybe ask me later in the Discord. Anyway, One more? Yeah.
Do young Stegosaurus have Thagomizer, or maybe what age did they grow it?
That's a great question. I don't think we really know yet. I mean, if you look at the young Stegosaurs right here, they do have those tail spikes in the illustration. I don't know if we have a good like baby Stegosaurus specimen that's complete enough to where we know whether or not they had those tail spikes. I'm not sure. When we go to Dinosaur National Monument tomorrow, we will see a baby Stegosaurus skeleton cast, and we can check if it has those tail spikes. I'm not sure. Yeah, I'm not sure. We should also check. I should hit up Rebecca Hunt Foster on Twitter and see if she's back from Wyoming yet. It'd be cool to see her, but I think she's probably still out in the field doing stuff.
The dinosaur we knew.
I think we'll probably miss her again.
It's not going to be friendly to us.
Rodan, sub for 4 months.
Thank you, Rodan. Holy cow! I appreciate your support. Yeah. Ooh, let's take a minute to look at this real quick. Here's a right front leg of a big old Stegosaurus. Look at the size of that humerus. Just look at that. My goodness. Really, really cool. And look at that ulna right there. Look at the giant olecranon process on the back. So, radius, ulna, humerus, carpals, metacarpals, phalanges. Really neat. This is from a huge animal. I mean, the Stegosaurs, their front legs are so much shorter than their back legs. This is a front leg that you're seeing right here. And so, yeah. And this is the largest Stegosaurus front leg ever found.
Let's protect our fossils, because if they're removed...
see how this front leg is as large as the back leg of the Stegosaurus on the platform?
Really?
Wow, that's amazing. So this...
Darknaze gifted Sith_Lord_ a subscription.
Almost.
Darknaze gifted a tier
Femur's
1
a lot
sub
longer.
to Sith_Lord_.
This guy's a very, very long femurs. But yeah, really cool. I have some ideas as to why there's such a big difference between the length of the forelimbs and the hind limbs, but I'm not going to talk about that yet. I don't want to get scooped. It's another potential paper idea to get published in the future. Yeah. Got some cool Jurassic Sea fossils there, including some ichthyosaur vertebrae. They just look like big old hockey pucks, kind of nondescript. Hoploseuchus, we will see that tomorrow as well at Dinosaur National Monument. That same cast. These cool tracks.
Darkness just forwarded a gift sub.
Who did?
Darknaze.
Thank you, Darknaze. Hey, really appreciate that. Awesome. Cool. Thanks for keeping me updated here, Larry.
Yeah, everybody deserves their thanks, because we really appreciate you guys.
Seriously, yeah, I'm here marveling at everything, trying to show you as best I can. So yeah. There we go. Here's more of that tree trunk there. Oh, cool. It's an Araucaria. Oh, super cool. So this is like a monkey puzzle tree. Big old conifer from the time of the dinosaurs. Check that out, Lordy. Look at this tree trunk.
Whoa.
That's really neat. That's really, really neat. And look at this sled that they had to build for it. Like, this is all custom woodwork to get this petrified wood out. Really neat. I wonder if this is from somewhere near Dinosaur National Monument. And I don't remember seeing this the last time I was here. And look, they've got butt pads there.
Is petrified wood dangerous, or?
Apparently, yeah. That's why they have it very securely restrained here, so it doesn't jump out and get you.
Jump out.
Yeah. But we use these. So Museum of the Rockies crews, we always called these butt pads, but I guess gardeners call them gardening knee pads. But we use those in the field all the time. We often use them for our butts, or for our heads, or for our elbows, while we're doing field yoga. That's what Denver called it, at least, Denver Fowler. You have to, like, contort yourself into all kinds of different shapes and stuff in order to be able to, like, work in a quarry, to be able to chip away the rock and everything and clean the bones, get them ready for extraction and for jacketing. We call that field yoga. So you might have, like, 6 different people, all in like a 10 square foot area, and they're all like contorted and like all working together, trying not to kick each other in the head or elbow each other in the back. And so those butt pads end up being really, really useful. They're kind of lifesavers because your body's in really weird positions, and you've got to cushion it in certain areas in order to keep from hurting yourself. Yeah. But check this out. This is a tree trunk, again from a monkey puzzle tree.
Just FYI, we are in a hype train.
Are we now? My goodness.
I know, we have a level 1 hype train.
Holy cow, everybody. Let's see how high we can get that.
Dinosaurs lived a long time ago. They were terrible lizards, don't you know?
Thank you, TJ Grillo. See, really appreciate that. Yeah. Thank you. Super cool. Man, we said sauropods are difficult to dig up. Look at this, though. I mean, at least this didn't have to be fully jacketed. And like, yeah.
Ragandar just gave us how many gift subs? 10 gift subs.
10, holy cow, Ragandar. 10 gift subs.
Thank you so much, Ragandar. And then Zerka gave us 300 bits.
Thank you very much for those bits.
Just
Holy moly.
10 subs.
TJ gave us another 100 bits, and Claire gave us 100 bits.
Thank you, everybody. Really, really appreciate that.
Thank you guys so much. We really appreciate you.
Again, we couldn't do this without you.
A
So,
long time ago.
thank you. This is
terrible lizards,
this is awesome.
don't you know?
I think we've probably just paid for our
I think we did. Yeah, which is really a really good feeling.
and maybe for gas too.
Yeah.
Gas and
Thanks,
food.
guys. Thanks so much.
Fantastic. Super cool. Super cool. That probably put us over a level 5, right? 10 gift subs? I might do it.
Dinosaurs lived a long time ago. They were terrible lizards.
Thank you, Balint, and thank you, Claire. I hope you're both enjoying the broadcast a lot. I'm really enjoying showing you all this stuff. Thank you for your monetary support. That means a lot. Who have we got right here? This is a hip of some kind of ornithischian. Is Camptosaurus, maybe? Yeah, there we go. Camptosaurus. Your classic ornithopods from the Morrison. Unheralded dinosaur from the Morrison. Doesn't get nearly enough attention. Yeah. Ilium up here. We've got the pubis with the forward projection and the backward projection, and there's the ischium, and there's some caudal vertebrae. It's the beginning of the tail going out there. And there are some caudal chevrons, these little bones that extend out of the bottom of the tail. All these tendons and stuff attached to. And look at those labels. Can you read that? It says UFH 2000 1.5. UFH stands for Utah Fieldhouse, like Utah Fieldhouse Museum. And all repositories, all fossil museums like this, they have an institutional abbreviation. And UFH is the one for the Utah Fieldhouse Museum. You've heard me talk about UCMP, or MOR, or AMNH. These are all different abbreviations for different museums. And paleontologists, we rattle these off like
no expense.
Like we're talking about our siblings' names or something like that. Very, in a very familiar way.
They have given
I have to keep in mind that not everybody knows what I'm talking about when I say AMNH or USNM or MOR. Anyway, different hips, different dinosaurs. They must have had an Allosaurus over here too with the hips for this display. They must have moved it to make way for this big carrier. Super cool. Super cool.
5 hype train, 0%. We haven't finished it.
Ooh, okay. Can we get all the way complete a level 5 here? I think we can.
TJ Girl just gave us 100.
Thank you, TJ Girl.
And Liza just gave us 100 bits and says thank you for showing us the dinos.
Thank you for showing us the
We've been
dinos.
getting a lot of just really kind words about the stream.
Excellent. I'm really glad you guys are enjoying this. Man, this was... So the first time I came through Vernal on this trip, I didn't think I'd be coming back. That was right when the encoder had died, and I was really looking forward to being able to show you guys this museum. This is one of my favorite ones in Utah, and I was so disappointed that it didn't work out. I'm so glad that it worked out today. This is awesome. This is really cool.
Tactical Sponge just changed things with those 5 gift
Tactical
subs.
Sponge just gave 5 gift subs.
Thank you, Tactical Sponge. I'm sure that put us over the top, huh?
It did.
They were terrible lizards, don't you know?
Thank you so much for those 300 bits. Thank you very, very much. Holy cow. There it is indeed. Everybody, thank you so much. Holy cow,
That's such a big deal, you guys.
Seriously.
Support us with gas. All the things that goes
Your
into a
modern
road trip.
support
We
team
really
is
appreciate
amazing,
it.
by the way,
So we
Landco
can bring
models.
all these museums to you guys.
Yeah.
Yeah.
Like I've said before, this is one of the most remarkable communities on Twitch. Thank you guys for being so awesome. Really, really appreciate that. Guys and gals and NBs and everybody else, thank you so much. It means a lot. It really does.
And another 100 from Empress.
Thank you, Empress Eliza. How very regal of you. I appreciate that. Check this out here. Oh, did anybody... Here, I'll put this question to everybody again. I don't expect anybody to get this, but I will be duly impressed if anybody can identify this very rare sauropod dinosaur from the Morrison. It's on display here. I've got some bones over there. I didn't show you yet because it's labeled. Which sauropod is this? Take some guesses. But right here we have Allosaurus. Lovely Allosaurus skeleton. This is a smaller Allosaurus. This is smaller than Big Al at MOR, and Big Al is not even a big Allosaurus. It's definitely a younger one.
Haplocanthosaurus.
Not quite Castor Ball, no. Javasaurus Studios and Rodan. You both got it. Haplocanthosaurus. One of the lesser known Morrison sauropods. Nicely done, everybody. We'll take a look at that in a minute. But, yeah. I love how this mural is arranged, too, where... Well, we'll get to that in a minute. But let me talk about Allosaurus first. We've seen a lot of Allosaurus so far on this trip. We'll be seeing even more Allosaurus tomorrow at Dinosaur National Monument. I just want to take the time and appreciate just how beautiful this skeleton is. Most of the dinosaurs that you see in the Morrison Formation, their bones tend to be kind of a darker gray, like verging on black. That's generally like the color of dinosaur bones in the Morrison Formation. So to see an Allosaurus skeleton in this color is just very different. It's novel in a way that, like, my brain goes, whoa, cool. To see it in this kind of, like, creamy tan yellow. Very neat. You, like, notice details in the neural spines and on the skull that you wouldn't necessarily notice if it were a darker color. The shadows just play on it differently. It's really neat. And I love this pose. This is super well done. It's difficult to, like, pose a dinosaur well and get all of the ribs and the vertebrae and the projections that come off of the cervical verts and stuff to all work properly together. This looks very dynamic. It looks alive. Looks like a living animal. I mean, if you were to x-ray a living animal, this is what you might expect. Really cool. This is super well done.
Why are the dinosaur bones there specifically black as opposed to other colors?
That's a great question. Well, we'll look at some of these right here. These are the bones of Haplocanthosaurus. These are the actual fossil bones, by the way. You see the specimen numbers painted on them there. And in the Morrison rocks tend to be kind of a reddish color. Sometimes around the actual bones, they're like, slate gray or lighter grays. But for whatever reason, in the Morrison, the rocks tend to be kind of red when they're on the surface, heavily oxidized. And but the bones themselves tend to be this color. Kind of a dark gray with hints of red. Really, really dark, kind of hinging on black. And it's got to have something to do with the local mineralogy. These would be, if they were rocks, you would say they're highly mafic, dark colored. I don't think we use the same terms for fossils. But yeah, something about the groundwater that seeped into these sediments and helped permineralize the bones, helped fossilize them. Left behind some stuff in there. It was very dark colored. So there you go. And there are exceptions to this. I'm sure there are Morrison fossils that are lighter colored, but for the most part, they tend to look like this. we should pay close attention to the color of the fossils tomorrow at Dinosaur National Monument. Okay. The ones in the quarry wall, and we'll see what those look like.
Yeah. Of the fossils have pathologies?
Here, probably, yeah.
What's a pathology?
It's an injury.
Okay.
Yeah. So some of these might show bite marks from allosaurs, maybe. This humerus is all scrunched up. I wonder if that's pre or post-mortem. Yeah. We definitely have some pathological fossils in Dinosaur National Monument. The thing about pathologies is that it's hard to tell sometimes if the breaks or gouges or whatever happened before or after the animal died. But if they show evidence of healing, then that shows that it happened while the animal was still around, so that the bone could heal, while the animal was alive. Like Big Al, the Allosaurus specimen that we saw at Museum of the Rockies, he's got a lot of pathologies that show evidence of healing. So he got those injuries while he was alive, and all those bones had an opportunity to patch themselves up a little bit. Anyway, speaking of Allosaurus, let's look at this real quick. Dominant predator in the late Jurassic. Lovely Bob Walters illustrations here. I like that a lot. This poor Haplocanthosaurus right in the middle of this scrum. Oh, man. Very cool. And here's Haplocanthosaurus over here. Again, there's a lot of sauropods from the Morrison. The Morrison is famous for its big long-necked dinosaurs. Haplocanthosaurus is one of those ones that you forget about because we don't have very many bones of it. I actually forget what group it belongs to. Is it like a Camarasaura? Is it a Macronarian sauropod like that? Is it a Diplodocid? Is it something else? A Cetiosaur or something? I don't know. Yeah.
There's evidence of something like osteoarthoma or other diseases that affect bones?
Certainly, yeah. There's some dinosaurs that seem to have something similar to osteoporosis in their bones. We've got evidence of like bone cancer in dinosaurs. We talked a little while ago about that Centrosaurus. I think it was a fibula that was found with this huge like bone tumor on it. It's like almost it's wider than the rest of the bone is. Just like this big old tumor blob on the side of its fibula, one of its shin bones. Yeah. So we get that kind of thing in the fossil record. Yeah, you got to know what you're looking at, and you got to have a lot of specimens so that you don't make a mistake and say, "Oh yeah, this is what this dinosaur's bones just looked like." You usually have to have a lot of examples of that animal to be able to pick out the weird things like that and go, "Oh yeah, this is strange. This is out of the ordinary."
Do any dinos have retractable claws, or is that only a mammal thing?
Yeah, I think it's just a cat thing. Yeah.
Cats are so cool.
Yeah. So dinosaurs like Allosaurus, their claws are just always there. See those claws there? They're just, always out. Just like in birds, just like in lizards, I guess. Forget I said lizards, just like birds. I don't want you to come away from this thinking that dinosaurs are lizard-like. So, yeah.
Did all dinosaurs lay eggs?
As far as we know, yes. Yeah. There were a couple of holdouts, like different dinosaur groups that we'd never found eggs from before. But as of last summer 2020, I think all major groups of dinosaurs, we have eggs from them. So yeah, we think they all laid eggs. Or all the females, anyway. Yeah. But here, I want to look at Haplocanthosaurus. This Haplocanthosaurus was found near Vernal. It is the most complete skeleton of this animal ever discovered, even without its head. Sauropods are kind of notorious for losing their heads. It's very rare that we find a sauropod skull, so it's not surprising that we don't have one for Haplocanthosaurus. We know this individual was very old when it died because paleontologists found signs of arthritis in its bones. We were just talking about that. Probably died of old age or disease rather than from a predator attack because its bones don't show any tooth marks. This Haplocanthosaurus is a new species. Is that so? It's found in the older part of the Morrison Formation from 150 million years ago, called the saltwash member. Cool. It is one of the oldest sauropods in North America. I think that's only because we don't have sauropods from like the Middle Jurassic yet. We need to find some rocks of that age and look for sauropods in them. Yeah. Pretty neat. And that is why over there, look over at the wall, there's this bit of canvas that's put over there, because we don't yet have a skull of Hapocanthosaurus. So what its head looks like is still kind of a mystery. Yeah, yeah.
Is there thought behind why the heads are missing? Scavengers, etc.?
Yeah, I mean that, and so it could be a number of different things. Sauropod heads are pretty rare because, like, these are really big animals, and oftentimes you don't even have, like, the end of the neck, let alone where the head would be. Sometimes it's just, you know, when you go to excavate a sauropod, they're so big that, like, it can be really, really difficult to dig a hole that large. Sometimes, like, I don't know, I've worked at sites before, like when we were digging up Yoshi's trike. That's just a Triceratops. It's not even sauropod sized. In the Hell Creek, we probably could have gotten its whole tail, or whatever was left of its tail, but we just ran out of time, and the hole that we had dug, the quarry that we had excavated, just wasn't big enough to encompass the whole animal. That happens with sauropods too, probably more often than we'd like to admit, just because they are such big animals. But also, you know, the head is really small compared to the rest of the animal. I mean, look at that illustration there on the back. And the head, by virtue of being at the end of this very long neck, the animals evolved so that their heads would be really lightweight. So they're made of very thin bone. Yeah, often like very strappy bones, like really, really thin. So the head is the most delicate part of the whole animal, really. And so after death, sometimes it just disarticulates and falls apart. Maybe the head gets bitten off by predators or scavengers. There's a million different reasons why we don't find sauropod heads, so we're really kind of lucky we have any of them at all. They're very rare. So anytime you find a sauropod head, that is a cause for rejoicing. Yeah.
70 feet long.
Still there at the dig
Tips
site?
the scales at a substantial
For Yoshi's trike?
35
Yeah,
tons.
presumably yes. Yeah, it's still there in the ground. Yeah. There's Kirk Johnson right there. Oh. Please press the button. Kirk Johnson used to be at the Denver Museum of Natural History in Colorado. But he is now, I think, director of the Smithsonian Institution. He's a big shot now. He's really cool. I got to talk to him. Oh, this is neat. Got to talk to him in Montana a while ago. Got to pick his brain. I think we were at the Hofbrau, little bar in Bozeman. He'd come to speak at the like Earth Sciences colloquium that we had at Montana State, and I like pulled him to the side and like asked him for some advice once, and it was really cool. He's a cool guy. You probably can't hear what they're saying right now. There's Jim Kirkland, state paleontologist here in Utah. Another really cool guy. And there's Kirk Johnson again. So he's a paleobotanist. So he works on Mesozoic floras. He's done a lot of work in the Hell Creek, for instance, looking at fossil plants.
There may not be a right answer. Science isn't about truth with a capital T.
Pretty cool. Anyway, I like how this exhibit is put together. You don't just have a mural here like you would in other natural history museums. This is a mural in progress. I like how it kind of talks about the process here of like reconstructing an ancient environment. Everything from the plants to the climate to the appearance of the animals themselves and how they're behaving and whether they're in groups or by themselves. It's cool stuff. I like this a lot. Pretty neat. Pretty neat. And this area over here, I feel like we've got some holdovers from an earlier time in the museum. We've got some old dinosaur models up there from days past. This is kind of cool. Hey, Lordy, come check this out. Make your own Jurassic exhibit. So, Lordy, build what you think a Jurassic dinosaur exhibit would look like.
Are these all Jurassic dinosaurs?
You're not doing too badly.
They are. Yeah, you really can't go wrong here.
Okay, I thought it was a trick.
No, it's not. This is cool.
Stegosaurus is going to be climbing a tree.
Climbing a tree?
Well, eating a tree.
There you go.
He's touching the tree.
Yeah.
Camptosaurus is hiding behind a tree. I love this.
Isn't this cool?
It's great.
Yeah. Diplodocus head down to gobble up low plants. That is what we think Diplodocids probably did.
Probably needed some ground ferns there.
There you go. Yeah.
This is fun.
This is neat. Yeah. I love that. I love this Stegosaurus illustration there too.
Take the spread to scare away predators.
That might be part of it. And Brachiosaurus, that's an interesting pose on the Brachiosaurus there. I'd love to talk to maybe Matt Wadle or Kerry Woodruff about Brachiosaurus and their posture. Brachiosaurs are usually shown with like upright necks like that, like a swan. This one's a little bit less dramatic there. Interesting, very interesting. I've got this area over here with like all kinds of little books and stuff for kids. Pretty neat. Oh, here. Let's check this out, Lordy. I wonder if you could do this. Maybe we'll let that area clear out a little bit first. There's cool. This is cool. These are not super up to... Oh, we were just talking about this. Wow, what a coincidence. This is that fibula bone on a Centrosaurus there. We've got bone cancer in a dinosaur, that big metal blob, big yellow blob there. All that yellow is bone tumor. Pretty cool. We actually talked about this live on my channel back when this was new news, right when this came out. This was it earlier this year or late last year? I forget. Yeah. Pretty cool. There's the reference there, August 2020. Okay, yeah. In the journal The Lancet Oncology. I wonder if that's the first dinosaur paper that was ever published in The Lancet Oncology. It's like a cancer journal. Very cool. Pretty neat. There's a bunch of kids running around over there now. We might skip that area. But I love this so much. It's like facsimile of what a dig site might look like. We've got this beautiful Badlands topography. This looks a lot like the area just outside Vernal and Dinosaur National Monument. We've got this reddish Morrison rock over here. And then there's a golden eagle just hanging out there. That's cool. Big old bird. And here's plaster jacket right here. You could tell. That's basically just hollow plaster there. And there's a mixing bucket, like we might use for mixing plaster. And yeah, block and tackle. I've never actually used one of those in order to get fossils out, but it happens. Here, can I issue you a challenge, Lordy?
Sure.
You don't seem super excited about that. That's right over here. Identification station.
Okay.
Okay. Look at the fossil above.
Mm-hmm.
So I think you're supposed to look at... Yeah, here, follow the directions. Look closely at the fossil. Begin making choices at the top of the triangle. Push the button of your choice. If your button turns green, you're right. If it's red, try again. Keep moving down until you identify the fossil. It's like a dichotomous
fossil?
key.
This one?
I think it is that right there.
I already had no idea if it eats plants or eats meat. I have no idea.
Really?
I know I should know this because I watch your channel. I feel like you're embarrassed that I don't know this.
I'm honestly a little embarrassed right now, yeah.
I think that this is a duck-billed dinosaur.
Okay.
And I think that they eat plants.
Okay, then go ahead.
Yes.
Green.
Ding, ding, ding. Ding, 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 ding.
All right, okay, so far so good. I feel like we should have the like, do you want to be a millionaire music playing, whatever it's called. Dun, dun.
All right, so tiny teeth with beak or shearing teeth? Shearing teeth? No, tiny teeth with beak. Nice.
Okay.
Nice. Okay.
Success so far? Okay.
All right, one more. Narrowhead or broadhead? Narrowhead. All right, broadhead.
No, you're right.
No, I was right. Okay.
So.
Yes, I was
yes.
right.
All right, you have advanced.
Stegosaurus.
To level 2. It is Stegosaurus. That's your favorite dinosaur.
That is my favorite dinosaur. I'm sorry, I didn't know.
I have
and
a
it's not even a duck-billed dinosaur either.
No, it's not. I have a Stegosaurus skull in my office. Like, I feel like you've seen it before.
I probably have. This is why I didn't want to do this with you.
Well, should I have you do this one too? This is the other dinosaur-related one. Okay. Let's see if Laurdee can go 2 for 2 here.
Walks on 4 feet, walks on 2 feet. I'm going to say walks on... Let's say walks on 2 feet.
Okay.
Yes!
You are correct so far.
Arms get plants or arms catch prey? Arms catch prey. Look at those claws. The claws.
Claws on there?
Yeah.
Okay.
Yes!
Okay.
Hands have 2 claws. Oh, Tyrannosaurus or Allosaurus. 2 versus 3.
We just talked about this, didn't we?
Allosaurus, 3 claws.
All right. Congratulations for Laurdee. Can we get some W's in the chat?
For winning?
Some GG's in the chat.
Big winner. Thanks, everybody.
Yeah. All right. Well,
that
cool.
Was fun.
Very cool.
Look at this guy.
Yeah, this is another Ophnelia, like we saw yesterday. This is this. I wonder if this is like what's his name's company that produces these. But these are this is the same cast that we saw yesterday. I'll give you a close up of the face. You'll recognize this if you were here for yesterday's broadcast. This is Ophnelia, little beaky plant-eating dinosaur from the Morrison. Yeah. And I like
these.
Ophnelia rex. So Tyrannosaurus rex isn't the only animal with rex as a species name. This one has it too. Ophnelia rex. Yeah. I mean, look at these older dinosaur sculptures.
I was going to say, yeah, by Bryce Davis.
Yeah. These are
pretty cool.
They are cool. Yeah, there's definitely some cool artistry there.
Artistry to them, yeah.
Yeah. But, definitely out of date. I won't dwell on why, but at least they are more up to date than these up here. Check that out. Little tail dragging sauropod. And Stegosaurus. Tail dragging action. Cool. And we've got more up here. Allosaurus. It's probably what they used to call Trachodon. Edmontosaurus up there. And Ceratosaurus up here. Pretty cool. I like that I can bring the camera up, taller than my eye line, higher than my eye line, so that you can see these cool things. Yeah. Pretty neat. Wow. Good job, Laurdee.
Thanks.
I think you underestimated yourself.
This is fun. This is fun.
Yeah. So yeah. Remember I was telling you how when there's outdoor stuff brought inside?
Yeah.
It's like tickles my brain. Because I have a dog's brain, of course. I see this kind of thing and I go, oh, cool. It's probably why I like tiki bars so much, too. I don't know. I just like this. I think it would be fun to make, too. Yeah. No, this is cool. I mean, for people who can't actually make it out into the field and see what the rock looks like and all this stuff, it's cool to be able to experience that indoors. especially during the winter. I didn't even think about that. Utah has some harsh winters, at least compared to California. Yeah. Coastal California, where we live. So yeah. It'd be cool to come here in December and, you know, look at all this stuff. Let's see. And of course, since we went through this whole exhibit backwards, this is the stuff where it's, you know, talking about what is a fossil and that kind of thing. Clues left behind in the fossilized way. Yeah. Pretty cool. Let's continue on through here. This actually talks about the process that we go through when we're looking for fossils. I get this question a lot, so it's cool to see a museum's take on this. Like, how do you go about finding dinosaur fossils? How does that start? Well, if you learn what we do, select a dig site and a type of rock known for fossils. Find out if the land where we want to dig is public or private. Contact landowners for permission or a permit to dig. Carefully survey the ground for possible fossils at the surface. We call that prospecting. And then dig up the fossils buried there and protect them in plastered jackets. Yeah. And then here's the why. You know, we talk a lot about the why here on this channel. Our understanding of ancient environments is only as good as the fossils we find. Fossils give us evidence of the evolution of life. The Morrison Formation is a great place to look for dinosaur fossils from the Jurassic, and we can share our fossil finds with museum visitors or with Twitch viewers. I'm so glad you could join me for this. Here, look at these bones eroding out over here. These might be modern bones. These might be like bison pieces up here. I like how these have been put in.
There's a snake back there.
Yeah. Got a rattler hanging out there. Yeah. Just minding its own business. Okay, and we have a video right here. Yeah, so I guess you're supposed to start there. We didn't do that. I wanted to see the dinosaurs last and the mammals first. To kind of save the best for last. And speaking of best saved for last, here we have Diplodocus. This is such an awesome specimen. So, I've heard it said before, and I believe it's true, this particular Diplodocus specimen is the best known dinosaur skeleton in the world. You know, here in the United States, in North America, we're very spoiled. We have a lot of dinosaurs. Other places in the world, they don't necessarily have that. But Diplodocus is one of those examples. This particular specimen, nicknamed Dippy the Diplodocus, is really like an American dinosaur ambassador that kind of showed the world what dinosaurs looked like. I'll tell you the story. So back in the late 1800s, there were American paleontologists striking out across the West in kind of the Wild West days, looking for strange and interesting and impressive fossils to bring back to the East Coast to put in their museums. And at one point, there were some researchers who were out there looking for sauropod dinosaurs, and they actually got some funding from the super wealthy industrialist Andrew Carnegie. He financed their work and financed the discovery and excavation of this dinosaur skeleton. This is back in a time when dinosaurs were still fairly new, and most people in the general public had never seen a dinosaur before. Now, some people here in the chat are going to be familiar with the Crystal Palace dinosaurs in England, how they were kind of like a way to introduce the general public to what scientists thought dinosaurs looked like at the time, way back in the 1850s. This is arguably far more important than the Crystal Palace dinosaurs, because that was a big deal in England and in Europe, but this dinosaur here, which is named Diplodocus carnegii, Diplodocus carnegii? I think that's, I've heard Carrie or Matt Wait'll say it. Yeah. After Andrew Carnegie, financed the excavation and transport and preparation and restoration of this dinosaur, he actually paid to have a bunch of replicas of it made, mostly out of plaster, and then sent to various heads of state around the world. So you will see an exact copy of this specimen in the museum in Paris. You'll see one in London. I think there's one in Beijing. There's one in Mexico City. I think there's one in Buenos Aires. They're all over the world. And so Andrew Carnegie, he was originally from Scotland, but he was immensely proud of his adoptive new home in the United States, and he wanted to share parts of America's wonderful fossil heritage with other people around the world. And so he gave these as gifts to various museums. And I think they ended up being housed in the museums, but they were officially it was a gift to the King of Spain or to the Queen of England or what have you. Call it fossil diplomacy, maybe, if you want to be that lofty about it. This was a wealthy guy just throwing money around at the time, and who knows what the real intent was or whatever. But the end result is this dinosaur ended up in different museums all around the world. And if you're watching from overseas right now, you might have one near you. And it's, a copy of this particular specimen. And I really can't emphasize heavily enough how important this was, because most people around the world, they had no clue what dinosaurs were. This is still a fairly new concept even in science, let alone, in popular culture. And so it was a big deal when these gifted skeletons were unveiled to the public in those various countries. This is really, for millions and millions of people, this was their first picture of what a dinosaur looked like. The whole reason that Diplodocus is such a well-known dinosaur to the general public is because of this specimen. So again, I can't emphasize heavily enough how important this is. And you can look up, there's a Wikipedia page for Dippy, the Diplodocus, and it has a list of the different cities around the world where you can see this skeleton. And it's Pittsburgh on the East Coast where the original is. There's London, there's Paris, there's Madrid, Buenos Aires, Mexico City, all of these kind of world capitals, big major metropolitan cities. And then Vernal, Utah is on that list too. So this might be the smallest town that has a Dippy skeleton in it. This might be the best one too, just in terms of how it's posed and everything, and the fact that you can walk right underneath her. I mean, super cool. So that's neat.
It's really cool.
I mean, really awesome. Do we have any questions right now?
Are you headed to the quarry tomorrow?
We are, yeah, at Dinosaur National Monument. Try and get there as soon as it opens tomorrow. It's going to be really cool. Look at that. Rib cage right there. Big pelvic bones. There's a great book about this, actually. I think it's called The Bone Wars by Tom Rea, I want to say. It's all about Diplodocus, about the discovery and excavation and unveiling of this skeleton here. Yeah, as you can see, the tail just keeps going. I mean, look at that. Look at that super long whip-like tail. Look at how small and spindly the caudal vertebrae get at the very end. You can probably barely even see them on the camera. Just astonishing how thin that is. Super long whip-like tail. And it's still kind of a mystery why these guys evolved such long, slender, spindly tails at the end. Was it used like a whip? There's some paleontologists who think so. There's a hypothesis that these guys could actually break the sound barrier. Like, the end of the tail would whip through that quickly, like a bullwhip. So as odd as it might be, you know, Chuck Yeager may not have been the first vertebrate animal to break the sound barrier. Maybe it was something like Diplodocus.
Belinda asks, was Dippy male or female?
We don't know, Bullet. We don't know. There's like 3 or 4 dinosaur specimens in the entire world where we can tell if they were male or female. For Mesozoic non-avian dinosaurs. Male and female dinosaurs seem to be identical to each other, unless you cut the bones open and look for like evidence of egg laying. Like, you can tell if a dinosaur was, if she was ovulating by looking at the inside of the bone. You can find medullary tissue sometimes. It's only happened a handful of times, but that seems to be the only way we can definitively tell if a dinosaur were male or female. I called Dippy
Did you ever, though,
she. I think people usually refer to her as feminine, but we don't actually know. Yeah.
Blue Gintaro just up for 2 months.
Thank you, Blue Gintaro. Really appreciate that. Yeah. Awesome. Your support means a lot to me. Here, we'll go take a look at the lab over here, too, for just a second. Big old prep lab in here. And look at that, like, giant engine hoist that they have. That looks like... might be some sauropod sacral verts right there. Sacral vertebrae from inside the hips. Very cool. Really neat. Here. Oh, and they're actually labeled. Very cool. Some Apatosaurus stuff. One of 3 Brachiosaurus humeri known in the world. Workstation C. Right there. Look at that. That's a humerus. So, upper arm bone right here of Brachiosaurus over there. That is fantastically large. That's so big. Especially because it's from Brachiosaurus. Brachiosaurus, the name means arm lizard. These guys have they've got longer arms than they have legs. And I think in Brachiosaurus, it might be one of those few dinosaurs where the femur is not the biggest bone in the body. I think the humerus on Brachiosaurus might actually be longer than its femur, which is kind of nuts. It doesn't normally happen that way. Yeah, check that out. We've got this guy working on some kind of sauropod vert right there. That's probably a caudal, looks like. Really cool. And he's using an air scribe. So, that tool that he's using right there, it's kind of like a tiny pneumatic jackhammer. It's got a very, very fine tip on it. And it's hooked up to an air compressor. So it uses compressed air to move that tiny, like, jackhammer tip in and out. And that helps chip away the bits of matrix, the bits of surrounding rock from the fossil. And we use air scribes on particularly hard fossil matrix, like the rock surrounding the bone. And, yeah. I've done some air scribe work in my day at UCMP and at MOR. And, yeah, very painstaking stuff. Gotta be super careful with it. It's a powerful tool. And it also can kind of make your fingers go numb if you're not used to it. Just having this thing, like, vibrating at high speed in between your clenched fingers all the time.
What kind of work do they do in the lab that would require a fume hood?
Oh, a fume hood? Well, yeah, so that would be like chemical work, like mixing glues and stuff like that. You might use like various kinds of acid for eating away at matrix surrounding the bone. If you're mixing 2-part epoxy, it might be a good idea to do that under the fume hood. There's all kinds of various chemicals that we'd use in a fossil prep lab. So yeah, a fume hood is definitely a good thing to have in there. And it looks like they also have dust collection in here too. Every prep lab we've seen so far in Utah, Laurdee, we've had a proper dust collection system. Yeah, that's what he's got right here. This tube, kind of like dryer tube, running up to there. It's sucking up dust so that he doesn't have to breathe it in.
How do you know where to stop chipping away? Just by color?
by color, by feel. Like, you kind of develop a sixth sense for this after a while. Yeah, I wouldn't trust anybody brand new to an air scribe to work on anything important.
Yeah.
You kind of give them some kind of like garbage bones to start with.
Yeah.
So that they can learn on them.
Yeah.
That's your training wheels. Yeah. It takes practice to be able to learn that, you know? Yeah. Wow, really cool. Again, a very clean lab. Most of the labs I've worked in are much, much dirtier than this. That's cool to see. They've got some big jackets in there. It looks like almost all the stuff they're working on is sauropod stuff. Got this guy in the green shirt to keep dust off of everything. You can tell they work really hard to keep things all tidy and clean in there. Some good laboratory protocols. Pretty neat. Wow. I don't know if he wants to be on camera.
Like, e.g. sinews or the leg.
E.g. what?
Sinew.
Oh, sinews. Oh, dark names. That's a great question. So in fossil prep work that I've done, I've never been like a professional preparator or anything, but I've prepped a lot of fossils in my day. And sometimes, if stuff is there that you don't expect to be there, you might accidentally prep it off. I was working on a Triceratops specimen once. I think it was called Mark's Trike 2, that may have actually had keratin on the frill of the Triceratops. And at first I was instructed to just take all that stuff off. And I said, hang on, slow down. What is this here? Like, what is this weird stuff? So I consulted one of the paleontologists there, and he's like, hang on, let's keep that on there actually. Maybe that's really important. So yeah, I don't know. You've got to use your discretion. You've got to be careful. Yeah. There's no manual for this kind of thing. It's all, you know, when you're prepping out a dinosaur like that, you know, you're doing something nobody's ever done before. You're making things up as you go. It's just the nature of the work, you know? Yeah. Actual dino skin? Well, keratin may be aerogent logician, yeah. I'm still not exactly sure what it turned out to be. I don't even know if we know yet, but yeah. Pretty cool. Hi there. But really neat. That's just so cool seeing this Diplodocus specimen here. It's just magical to walk underneath this. I wish you could be here with me right now. Just an amazing animal. And he's made out of hollow plastic. I wonder if anybody still has the molds for this, if we could make another copy. Yeah. Such an important dinosaur. Dippy. I don't know. Sorry I keep repeating that, but kind of starstruck being here. Yeah. The name Diplodocus means double beam. And I think that's in reference to these caudal chevrons right here, where they kind of fuse together along this section before they unfuse there. Now, the original specimen of Dippy was actually a composite. She was made of several different animals. There were, I think, like 4 or 5 different Diplodocus specimens, and I think there was even some Camarasaurus bits thrown in there too. I want to say some of the pedal digits were actually from Camarasaurus. And I wonder if this particular mount reflects that, or if that's been corrected. But, yeah, back in the day, nobody had a complete sauropod skeleton like this. This was, yeah, and the one that makes up the majority of the skeleton was the most complete sauropod ever found up to that time, I think. And I want to say the entire tail, actually, was a different Diplodocus specimen. And the head was, too. So as important and beautiful, breathtaking amount as this is, it's still, like many things in dinosaur paleontology, kind of represents a work in progress, you know? Stuff to be improved upon. So yeah. Anyway, what do you think, Laurdee? About time to wrap this up?
I think so.
Yeah? Alright, well, let's stand under the Diplodocus here, and we'll find somebody to raid, and we will end this stream. Let's see here. There we go. Gotta open up my Twitch app real quick. And we've got Marine Mammal Rescue, Sea Nut Bush. Isn't it? You know, we should raid Oddbone Mo.
I was going to suggest Oddbone Mo.
Yeah, I think she'd really appreciate it. And what an appropriate place to start a raid from. So, go ahead and open up my channel, go into the chat, and
I see lots of nice messages coming in chat. You guys are also very welcome. We love doing this. We love having you guys with us on these cool museum trips. It makes it so much more fun to be able to take you guys around with us, answer your questions, hang out with you guys. It's like we're going on like this cool field trip with all of my friends. Like, it's really, really cool.
It seriously is, yeah. I'm so nice to be able to share this with everybody, and I hope you get some sense for the wonderment that I feel when I'm walking through here, and I hope you feel some of that too. And I hope if you ever are in this part of the world that you will visit the Utah Fieldhouse Museum in Vernal, Utah. It is definitely worth a trip. So without further ado, I think we'll go ahead and start this raid. We're going to go say hello to Oddbone Mo. She does like taxidermy, osteology. She works on animal bones. I think you're really going to like her channel. So without further ado, everybody, we will see you tomorrow from Dinosaur National Monument.
Yeah, we will be streaming early tomorrow.
Early tomorrow, yes.
Probably around 9 a.m. our time. We're in Utah, so that's mountain time.
Mountain time, yeah.
Around 9 a.m. mountain time, and then we will be streaming again in the afternoon, maybe around like 3 or 4. We will be letting you guys know on Discord.
Great. All right. Thank you, everybody, and let's get this raid started. All right. See you later, everybody. Now it says ready to raid. Okay, there we go.
There we go.
Cool.